This episode is brought to you by Nordic Naturals, the #1 selling fish oil brand in the U.S. More than 80% of Americans, that's probably a lot of you listening, including me, because I do measure my omega-3s, do not get enough omega-3 fats from their diet. That is a problem because the body cannot produce omega-3s, an important nutrient for cell structure and function. Nordic Naturals solves that problem with their doctor-recommended, and in fact, this brand was recommended to me by one of my doctors, Ultimate Omega Fish Oil Formula. So the Ultimate Omega Fish Oil Formula for heart health, brain function, immune support, and more. It's incredibly pure and fresh with no fishy aftertaste. So I have been taking Ultimate Omega for the last 2 months or so, and this fishy aftertaste issue has been a problem for me, and has actually with other brands induced some nausea after a few days. And Ultimate Omega has been as clean as a whistle. I've had no issues whatsoever. And if you are vegetarian or prefer to alternate, I ended up alternating 2 products, and that is #1, the Ultimate Omega Fish Oil Formula, and also the Algae Omega, which is plant-based EPA and DHA. That's also from Nordic Naturals. So I ended up getting both of those products, and it has improved my recovery from workouts. It's improved my sleep. It has improved my mood. And I know that because I pulled out a lot of other variables. In any case, back to the read. All Nordic Naturals fish oil products are offered in the triglyceride molecular form, the form naturally found in fish, and the form your body most easily absorbs. Their Ultimate Omega Fish Oil is offered in soft gels, liquid, and zero sugar gummies. Nordic Naturals fish oils are Friend of the Sea certified and sustainably made in a zero-waste facility powered by biofuel. They're also non-GMO and third-party tested, surpassing the strictest international standards for purity and freshness. Want proof? You can visit their website, where they provide certificates of analysis for every one of their products. So go to nordic.com, Nordic, Nordic.com, and discover why Nordic Naturals is the #1 selling omega-3 brand in the US. And while you're there, use promo code TIM, T-I-M, for 20% off of your order. That's Nordic.com and code TIM for 20% off of the fish oil with no fishy aftertaste. All upside, no downside. Try it out.
These statements have not been evaluated by the Food and Drug Administration. This product is not intended to diagnose, treat, cure, or prevent any disease.
This episode is brought to you by 8 Sleep. Temperature is one of the main causes of poor sleep, and heat is my personal nemesis. I've suffered for decades, tossing and turning, throwing blankets off, pulling them back on, putting one leg on top, and repeating all of that ad nauseum. But now I am falling asleep in record time. Why? Because I'm using a device that was recommended to me by friends called the Pod Cover by 8 Sleep. The pod cover fits on any mattress and allows you to adjust the temperature of your sleeping environment, providing the optimal temperature that gets you the best night's sleep. With the pod cover's dual zone temperature control, you and your partner can set your sides of the bed to as cool as 55 degrees or as hot as 110 degrees. I think generally in my experience, my partners prefer the high side, and I like to sleep very, very cool. So stop fighting. This helps. Based on your biometrics, environment, and sleep stages, the pod cover makes temperature adjustments throughout the night that limit wake-ups and increase your percentage of deep sleep. In addition to its best-in-class temperature regulation, the pod cover sensors also track your health and sleep metrics without the need to use a wearable. Conquer this winter season with the best in sleep tech and sleep at your perfect temperature. Many of my listeners in colder areas, sometimes that's me, enjoy warming up their bed after a freezing day. And if you have a partner, great. You can split the zones and you can sleep at your own ideal temperatures. It's easy. So go to 8sleep.com/Tim, spelled out 8sleep.com/Tim, and save $250 on the pod cover by 8 Sleep this winter. 8 Sleep currently ships within the US, Canada, the UK, select countries in the EU, and Australia. Optimal minimal.
At this altitude, I can run flat out for a half mile before my hands start shaking.
Can I answer your personal question?
Now would seem an appropriate time.
What if I did the opposite?
I'm a cybernetic organism, living tissue over metal endoskeleton.
Tim Ferriss Show.
Hello, boys and girls, ladies and germs. This is Tim Ferriss, and welcome to a very special episode of The Tim Ferriss Show. This is an episode that I think might be an example of peeking around corners. So what we are going to talk about, what we discuss in this episode, I think may be a component of the future of mental health treatments in the next, say, 5 to 10 years. It's at least a sample of it. My guest is Nolan Williams, MD. You can find him on Twitter at Nolan R-Y Williams. And Nolan is an associate professor within the Department of Psychiatry and Behavioral Sciences at Stanford University School of Medicine and director of the Stanford Brain Stimulation Lab. And we're going to go deep into a lot related to brain stimulation. He has a broad background in clinical neuroscience and is triple board certified in general neurology, general psychiatry, and behavioral neurology and neuropsychiatry. Themes of his work include examining spaced learning theory and neurostimulation techniques, development and mechanistic understanding of rapid-acting antidepressants, and identifying objective biomarkers that predict neuromodulation responses in treatment-resistant neuropsychiatric conditions. That is a long way of saying that he specializes in looking at, I would say, and these are my words, of course, cutting-edge treatments and new technologies that can be applied to treatment-resistant psychiatric disorders, let's just say. So treatment-resistant depression, things that are notoriously difficult to address like OCD, there are many others. Nolan's work resulted in an FDA clearance for the world's first non-invasive rapid-acting neuromodulation approach for treatment-resistant depression. And I've tested this myself, and we get into this in the conversation. He has published papers in Brain, American Journal of Psychiatry, and Proceedings of the National Academy of Sciences. Results from his studies have gained attention in Science and the New England Journal of Medicine Journal Watch. He received 2 NARSAD Young Investigator Awards, the Gerald L. Klerman Award, and the National Institute of Mental Health Biobehavioral Research Award for Innovative New Scientists. Again, you can find him on Twitter or X at Nolan R Williams. We'll link to this in the show notes as well. And you can find him online at nolanrwilliams.com. I really enjoyed this conversation. I think it is very important, highly tactical, and we also discuss things like ibogaine, which are seemingly unrelated to neuromodulation, and yet Nolan is an expert, very well versed in multiple disciplines and in multiple toolkits, pharmacological and non-invasive neuromodulatory. And it's this combination, this rare Venn diagram, that makes him incredibly interesting to me. So I hope you enjoy this conversation as much as I did. And without further ado, Nolan Williams, MD. Dr. Williams, good to see you, sir.
Yeah, thanks, man. Thanks for having me.
And I thought we would start with a personal story, not your personal story, but a story of Deirdre Lehman.
Yeah.
Could you tell us who this person is, how it fits into your story? But let's begin with just a description of Deirdre.
So Deirdre is maybe in her 50s, 60s, female in Bay Area who has suffered from bipolar disorder much of her life and pretty successfully treated for the mania side of things over the years, had a psychiatrist taking care of that part in Marin, and happened to slip into this pretty severe depressive episode a couple of years back. It's been maybe like 4 or 5 years now. And her psychiatrist had actually gone to see a talk that I gave at this mood disorders day, like the year before. We were talking, it was really early on when we were working on our rapid acting neurostimulation approach. So the psychiatrist had heard the talk, and then her patient kind of fell into this really bad suicidal depression. And so she reached out to me to treat her. And I got on the phone. I'll never forget, it was like a Wednesday. And I got on the phone with her psychiatrist, and she was telling me symptomatically how bad off she was. And I was like, I don't think we can treat her outpatient. She's like way too ill. I think she needs to go to the inpatient hospital. So essentially gave her some information on how to do that. So I see her the next morning, and she's in really bad shape.
What does that mean? Like, how did that show up?
When people are at the level where they like kind of definitively need to go into the hospital, they're not really totally communicative anymore, and they've got some cognitive issues sometimes. And so in her case, she couldn't look you in the eyes. You look at the ground, and she was doing this rocking thing, which you can see in pretty severe depression. It's kind of these catatonia overlap symptoms. I mean, she's like at the kind of the very end of the spectrum, one of the highest severity patients we've ever treated. So she was like a score of 50 on the MADRS out of 60, like very, very severe, right? And just rocking and not really talking. And and the husband's recounting everything. And she had bipolar 1. So she was hypomanic, I think, or manic, like 2 weeks before, and then dropped into this very, very severe depression. So it was her daughter and the husband, and they're sitting in the room with me, and I've said, they want me to treat her. And I say, listen, like, it's Friday. We go Monday to Friday. Like, you have to find a way, basically, to keep her well from now until Monday. And that means...
And by well, you mean safe, like preventing
safe.
self-harm.
Yeah, exactly. So keep her not having a suicide attempt, basically, from now until Monday. She's very suicidal. And I said, you're going to have to, like, take every knife, I don't think any guns, but gun, chemical, like scissors, everything out of the house. All of it has to go. And you guys have to be on like a 24-hour, watch until Monday. And so Monday morning rolls around, and we bring her in. And the craziest thing, we had like a repair on the motor threshold coil, which is the coil you use to kind of get calibrated on the intensity. And it shorted out the device and blew the capacitor bank up on the first stimulator.
Blew your flux capacitor.
Yeah, at like 7 a.m. And I mean, you can't imagine how stressful that was. So we had a second machine. I'll tell you about this later, but we were running this, trait hypnotizability modulation study, and it was over at the scanner. So it was like pretty far away. And this thing's weigh like 100 pounds. So I had to send my team over there, run over there and grab it, bring it over. And luckily we were able to kind of get her going and treat her with the second machine. She was in really, really bad shape that morning. And by 5 o'clock that afternoon, she was basically normal. And the next morning, she was like totally zeroed out and completely normal.
Meaning no suicidality.
Meaning no depression, no nothing. I mean, she looked like any person walking the street, like totally normal. And that was in 24 hours. And we've seen this with bipolar patients quicker. Right, it'll happen really quick for like a bipolar 1 patient. You can get it done sometimes in a day.
Just for clarity, by get it done, and don't worry, people listening, we're going to define terms and get into all this, but you're talking about accelerated TMS.
Yeah, we're talking about accelerated TMS. Our rapid acting neurostimulation approach, we're able to get people out of these states and into normal mood, and in short periods of time, generally, like 2.6 days on average for major depression patients, but it's quicker with bipolar, we've seen, especially with bipolar 1 patients. So she was totally out of it in 24 hours. I remember it was like right around July 4th or something. And so we, the whole team left. I guess we'll talk about caffeine later too. So my wife and I are like big Phil's Coffee fans. And so I'll never forget this either. So we go down to the Phil's Coffee in Palo Alto. After I saw them, I'll never forget it. Clark Lehman, her husband, was also went to Phil's, didn't know I was going to be there. And I look over and this guy's just kind of staring at me. And I was like, hey, how are you? Good to see you again. I just saw the guy like 10 minutes ago. And he's like, I still don't understand what happened. And it makes sense, right? Like to take somebody from the worst you've ever seen them mood-wise to like normal in such a short period of time was remarkable for him. And, it ended up being that, after that period, they actually went out and really were helpful with a lot of the philanthropy that led to the trials being funded and ultimately the clearance. And Clark and Deirdre really were advocates and have continued to be advocates for this to kind of get it out into the world. And it was totally based off of that experience of him feeling helpless, and going from that to feeling like it was all solved. And I think she went maybe a year completely asymptomatic, ended up needing to get retreated again at some point, but gets like these little touch-ups here and there and is able to stay well ongoing. And depression, as they tell me, depression's not her problem anymore. And so that's good. She's a great illustrative case of what this can do, and I think what the promise of it can be.
What I'd love to talk about next is not necessarily direct mechanism of action, but I'd love to hear you just explain a snippet that I pulled from your conversation with Andrew Huberman, which was a very good conversation. Specifically, it was about, and I'm not going to use the right terminology here, so bear with me as a layperson, but the sequencing or abnormal/pathological sequencing of activation or activity in different parts of the brain. So I don't know if it's the anterior cingulate.
Yep.
I think you know what I'm alluding to here. Would you mind just explaining that? Because it was something that I had never been exposed to, and I found it deeply fascinating. And I'll just also mention as context for people who are listening to this, that part of what is deeply interesting to me about a number of the different tools and modalities that you explore in depth is not just the speed of action, but the durability of effect.
Yep.
Super potent combination and very unusual, from what I can tell, combination of things. All right. So as far as the sequence of activation goes, could you explain what I'm referring to?
We published a paper in the Proceedings of the National Academy of Science. I guess it's been about 6 months ago now. So one of the former research track resident postdocs in the psychiatry program at Stanford, Anish Mitra, who's now junior faculty, was working with Carl Dijsselroth and I during that training phase. And Anish had this interest in a specific way of looking at brain imaging, particularly this type of brain imaging called resting state functional connectivity, MRI. And so resting state functional connectivity, MRI, has been around for a long time. The resting state part of it is basically you tell the person to sit in the scanner and let their mind wander. So that's kind of the resting state or the default mode, however you want to think about it. And functional connectivity, what that means is it's the brain regions that have blood flow that is time locked with each other, right? And so essentially these connected brain networks, the blood flow will go up or go down in those areas in a time locked fashion. And blood flow is
By time locked, you just mean at the same time.
At the same time.
Correlating.
Yeah, exactly. Yeah. And so blood flow is a surrogate of electrical activity. It's hard to see electrical activity kind of deep in the brain. People see it at the surface with EEG. But with MRI, you use the blood flow as like a surrogate of the electrical activity. And it makes sense if you're using glucose in a brain region because you're using that network, then you need to have cerebral autoregulation so the blood vessels increase and they dilate and more blood goes into that area. So it's just like a response to increased activity. And so you have these increases in blood flow that are supposed to represent electrical activity that are in different separate nodes in the brain, and they come on roughly at the same time. And we've known that for a while. Anish got very interested in this idea that the timing of the blood flow is consistently temporally offset between these nodes so slightly that people ignored it for a long time, but he was able, through using various math, able to show that there's a slight offset of the timing such that one brain region slightly comes on before the other. And that's interesting because that infers some level of causality, right? And so instead of the whole network coming on at the same time, maybe it's just one area and it's signaling the whole network on, you know, and it's so quick that you see it as all like this, but really it's more like this, right? If that makes sense. Like it's coming on all at the same time, but from this network node kind of turning this one on, turning that one on or something.
Right, like the lead domino matters.
Yeah, that's right. The lead domino, exactly. So in the case of mood, it looks like the dorsolateral prefrontal cortex, the area that's involved in control, precedes slightly the cingulate cortex. In our normal healthy control population, essentially nearly everybody had that directionality. In the depressed cohort, 70% of them had it flipped, where the cingulate was temporally in front of the dorsolateral, but not everybody. And if you just had that information, you wouldn't know what to make of that. Like, why is it some people and not others? But what was interesting is when he looked at the folks that had it versus the ones that didn't, the ones that had it were the ones that were responsive to our kind of, when we'll talk about, you know, what SANE is and the rapid acting neurostimulation approach in detail, I guess, later. But the folks that responded to SANE, responded to this rapid acting TMS approach, were the ones that had the biomarker, and the ones that had no change did not have the biomarker and looked like a normal healthy control. And the signal on the post scan flipped to look normal in the folks that responded, had the biomarker, and then their brain changed after. And so the post scan looked just like the pre-scan on the folks that didn't clinically change and the normal healthy controls. You know, we see this sort of test all the time in medicine. You know, 10 people come into the primary care doctor's office with blurry vision, urinating a lot, drinking a lot, headache. A lot of those folks probably have diabetes, but not all of them. Some of them have, you know, migraine headache and need glasses and, you know, some other things. And it looks like a diabetes presentation, but when you go and do the blood sugar is normal. And then you go, and in the folks that have elevated blood sugar that look like they have diabetes, you go and you give them a diabetic medicine, and then it normalizes. So the blood sugar after looks like the blood sugar of a normal healthy and looks like the blood sugar of somebody that symptomatically presented but didn't have diabetes. And so it was nice to see this, and we're replicating this now. We have money from the National Institutes of Health to do that. But this idea that we're able to have a test that would change, and the same thing that signals that there's an abnormality is the thing that changes later. And that's more rare in psychiatry, right? To be able to have all of that line up. So we're pretty excited about that and hope to see it. It does replicate in the larger population of patients. But it's as a conceptual idea, it's an important conceptual idea, this general idea of being able to use neuroimaging or whatever it is, EEG, whatever it is, to type different people that are presenting with similar symptoms and be able to say, okay, you're going to respond to this and not this, or vice versa. I think that's part of what we need for psychiatry, right? Because people spend just so much time in their lives trying to find the answer, and we don't really have any tests.
Trial and error.
Yeah, it's a lot of trial and error.
It's like pharmaceutical, ready, fire, aim.
Yep.
In a sense. And this raises, I guess, just a meta observation / question. Perhaps you could just discuss this briefly, which is, it seems to me like there have been, and this is part of the impetus for us having this conversation, part of the impetus for me in the last, let's call it half year, paying a lot of attention to accelerated TMS, which is there have been these dominant paradigms in certain types of, let's call it psychiatric treatments for things like depression, treatment-resistant depression. And it seems like a very dominant paradigm for a period of perhaps several decades has been these chemical imbalance theory of psychiatric disorders. So you have a serotonin issue, therefore we're going to treat it in these following ways. You have such and such an issue, so we're going to give you SNRIs. And then, like you said, it's a lot of trial and error to figure out what works. And even if something works, it may often only work for a period of time.
Yep. Mm-hmm.
So it seems to me, and I want you to absolutely fact check and correct everything that I'm saying, but that part of the reason that the research you're doing and that others are engaging in is so fascinating is that it presents an alternative paradigm through which you could look at certain disorders, right? Like, oh, wait a second. Well, maybe this person's car, when you turn the ignition, is just tripping things in the wrong order. And if that's causal, we could try to address that. And then maybe that addresses what we might have otherwise perceived as a chemical disorder. I have a lot of follow-up questions, but is that a helpful way to think about this? Or what would you add to that?
There's been, I would argue, like 3 eras in psychiatry, what friends of mine have called psychiatry 1.0, 2.0, 3.0. And, the first era was this era in and around Freud, and this idea that it was a content issue and a life experience issue, which is partially true. It's not that that's not true. It's just not complete. And so then the solution is a content solution, a la initially psychoanalysis all the way through kind of modern forms of psychotherapy. The limitations of that led us to psychiatry 2.0, right? This idea that we serendipitously found the first antipsychotics, the first antidepressants, and we were able to deinstitutionalize primarily schizophrenia patients out of inpatient asylum stays with these drugs, which kind of flew in the face of this being a content issue.
What was the first antipsychotic?
Thorazine.
I was going to say Thorazine.
Yeah.
I don't want to take you off track, so keep track of where we are. We're at 2.0.
Yeah.
How was it serendipitously discovered?
If I remember correctly, I think it was like an antibiotic or something like that, and they were trying to develop that drug out for something completely unrelated and happened to give it to some patients with schizophrenia, and they had a dramatic improvement. Yeah.
I would love to read a book that is just a collection of case studies like this, right?
Yeah.
It's like sildenafil, right? Viagra. It's like for angina or whatever.
That's right.
And then the male patients are like, why aren't the male patients sending their meds back? Oh, wait a second.
That's right.
Here we go.
Yeah.
Fascinating. All right. So Thorazine and the serendipitous discovery of, oh, wait a fucking second. This seems to not necessarily negate, but certainly render incomplete this pre-existing paradigm.
Yeah, that's right.
Then where does it go from there?
So then I think that, to your point, there was this accumulation of assumptions around, well, if we're moving all of these chemicals around in the brain, then it must be that there's, a deficiency or an imbalance or whatever. And that led us to recent history where there's quite a bit of prescribing of oral antidepressants and all that stuff. And, the third era, this kind of circuit era that I think we're in now, and I'd argue we kind of were entering in 10 years ago, but I think we're pretty squarely at the beginning of now, flies in the face of that, right? If I can take a patient as severe as Deirdre Lehman, get her out of it in a very quick time frame and looking normal and holding that for a long time, and there was no chemical exchange, right? There's nothing that went into her system, then it gets you into this newer way of thinking about it. It's a circuit problem. The useful thing about this framing, one, it's seemingly consistently true in the sense that we're through all the various modalities seeing these differences, but more importantly, it lets you integrate past ideas into that concept. Drugs act on circuits, therapy acts on circuits, but focal neuromodulation is a really direct way of acting on those same circuits. And so from a patient standpoint, I think it's very empowering because we're not saying to the patient, there's something inherently like missing or too much for you in the sense that you're constrained to having to take these exogenous chemicals to kind of stay well, but rather like there's a circuit, there's a misfiring sort of problem. And if we can reroute that information, then you can feel well. And I think that there's a level of empowerment that comes with that. One of the things that patients always tell me after they get well with some of our, stimulation approaches is that they kind of look at it and say, well, I may get depressed again, but I don't think I'll ever get suicidal at that same level again because I know that I've got a way of getting out of it and it's my own volition to choose to do that and it's something I can tolerate and I feel normal.
So I'd like to highlight that last part because not that I'm the world's foremost expert in suicidal ideation, but as someone who came very close to offing himself in college and really just by a series of lucky events ended up not fulfilling that, it's the hopelessness. I mean, for me and for a lot of people, it's the feeling that nothing can fix this. I am broken. I am permanently broken. There is no option other than trying to silence this voice in my head. And the only way I can think of doing that is by ending my life. But once you experience, even more so, something that alleviates that, especially with any type of durability, doesn't need to be forever, but some type of durability, and especially if it's rapid acting, right?
Yep.
Then you feel like you have a plan B. And that is incredibly empowering. Let me ask you a few questions. The first is, this type of neuromodulation, is that synonymous with a term that I came across? I don't know who coined it. It's a nice term, electroceuticals, or are those different?
Yeah, it's part of that broader term of electroceuticals. Yeah. And so what we had done with what we called SANE or Stanford Accelerated Intelligent Neuromodulation Therapy is that we came up with a way of reorganizing conventional TMS, which had been around for some time, reorganizing it in time and in space, right? And so with conventional RTMS, it had developed in the mid-'80s, first used as a therapeutic within clinical trials by my mentor, Mark George, when he was at NIH in the mid-'90s, and approved by the FDA in the kind of mid to late 2000s. It utilized average skull positions to find an average spot to stimulate, which, at the time, given the technology that was available, that was the right call, right?
Can I pause for 1 second just to give some additional context?
Yeah.
What does TMS stand for?
So transcranial magnetic stimulation.
And it was originally developed for what?
As a motor probe by Tony Barker in the UK. And the idea is this idea of Faraday's law. So Faraday's law is this idea that if you pulse a magnet, you can generate current in electrically conducting substances. So if I take an electromagnet, if I take a TMS machine to the beach and I try to pulse the sand, nothing's going to happen because sand is not, as you know, electrically conducting at all. It's an insulator. And so if you put a TMS coil or any electromagnet next to a wire, a copper wire, or speaker wire, or whatever, you can generate current in that wire. If you put the coil on the head, it will bypass the skin, scalp, skull, and induce current in the electrically conducting substance in the brain, the kind of brain tissue, right? And so you're able to selectively turn on cortical neurons without really interacting with much of the rest of the head. People do feel something because of the nerves in the scalp, but your brain can't feel anything. So that's scalp nerves. And so if you, as they did in the 80s, just kind of send a single pulse, it doesn't really change the brain, but you can probe the brain, right? So I could take that coil from the mid 80s and I could put it over my hand representation and make my thumb move. I could put it over my wrist representation of my brain. I could make my wrist move. And it's organized in this stereotyped way such that essentially the head face area is like closer to the ear, and you can march up to the midline of the skull such that when you get to the midline, you're able to actually move the foot and the leg. If you have a certain kind of coil, you can do that. And so you can actually probe the entire motor system and make all of it move without having any volition to it.
Question, what is the value of this probe?
So the value of a probe itself is just, as they
figuring out
the
the mapping.
Yeah, it's like it's a mapping exercise initially, right? Like, where is everything? Is it the same in everybody? Is it consistent? And they wanted to kind of have a way of doing that non-invasively. Penrose and others had been doing this invasively as neurosurgeons for 100 years, I guess 50 years at that point. And so they wanted to be able to emulate what the surgeons could do in epilepsy patients when they're doing epilepsy surgery non-invasively. And then what folks realized over the next 10 years is we can send a signal into the brain that's like Morse code and basically send this signal to change the excitability of the brain. And we can measure it, if we do it in motor cortex, by how much the thumb moves with a set amplitude out of the machine. So if I get X movement from stimulating here, I can make the thumb move X amount, and then I send this Morse code signal into the brain to tell it to tone down or to kind of be less excitable. And then I send that same intensity back in, the thumb will move half as much. And so you've toned down cortical excitability. If instead I get this measurement of X, and then instead of putting in what we call inhibitory or depotentiating stimulation, we put in excitatory potentiating stimulation into the brain, and we do that, and then we measure again, it'll be 2X. So we knew by the mid-90s that we could actually move around how excitable the brain was in these normal, healthy, control volunteer motor cortices. And so the aha moment for Mark and his team was this idea that depression at that time on PET scans, on SPECT scans, was this kind of hypoactivity, hypometabolism.
Meaning lower.
Yeah, lower activity, lower metabolism of the prefrontal cortex, where the prefrontal cortex just isn't as active, isn't as robust as it is in normal healthy controls. And so he had this idea, well, could we use this excitatory stimulation to drive up activity? And so that was the aha moment in the kind of first version of this. But they were super careful. There'd been some seizures in the early days from trying to figure out how all of this works. And so they wanted to do a stimulation approach that wasn't going to have much in the way of risk. And so they had this once a day, very extended protocol. And because of the mid-90s, it was very hard to get cheap brain scans on patients. And so this idea that they were going to have to use kind of average coordinates to target it. And so they get average skull measurements, and then they would do kind of a low dose approach once a day and do that out for weeks. And then it extended out to months. And so the original TMS trials and the original approval was this less efficient version that basically utilized kind of a low efficiency signal into the brain and used kind of average coordinates to place the coil.
So average coordinates meaning, just by clumsy analogy, like we can't take an X-ray of you, but we do have 100 other X-rays that seem to indicate roughly this is where you have your fracture. So we're going to aim at those coordinates.
That's right. Yeah, that's right.
And the once a day protocol, I've heard the number 36 from somewhere, but is it somewhere in generally like the 30 to 40 session range?
Yeah, that's exactly right.
So we're looking at, let's just call it for a placeholder, 30 to 40 sessions, one per day. And to perhaps not necessarily conjure an image, but remove an image from the minds of some listeners, they may be thinking, this is a beautiful mind. This is somebody chomping down on a wallet or a piece of wood, getting electroconvulsive therapy.
Yep.
These are not the same thing.
Yeah, it's actually the opposite. So in the goal of electroconvulsive therapy, or ECT, which has been around for 100 years, is to produce a therapeutic seizure. And some people with autobiographical memory troubles, it's pretty underutilized as a treatment in psychiatry because of these issues, because of particularly One Flew Over the Cuckoo's Nest and that story. And that movie culturally has actually had an impact on ECT. And it's one of these things that's kind of, for a lot of patients, a last-ditch resort because of the concerns around the side effects. TMS is different. You're not trying to induce a seizure. In fact, you're not trying to, have any sort of change in cognition. I always tell patients it's really boring. So, we have like Netflix running in the background and people have their Netflix movie that they keep watching every day. And it's basically just, once folks get used to it, it's just part of a routine where they're sitting there and watching their show or whatever it is, and the stimulator is turning the brain on. And unlike ECT, there's no anesthesia. There's really no need for anything. You can do this in an outpatient setting. But the old forms of TMS are extremely slow. You can't use that in a psychiatric emergency. And so, this is something that happens over a couple of months. And it's tricky for some people. Like if you're a working person and you have to do conventional TMS during business hours, and you basically have to tell your boss or sneak out of the office or whatever it is and go do an hour and a half during the middle of the day during like standard kind of banker's hours to be able to do this. And it's hard to do that over a couple of months. And it doesn't address these kind of high acuity emergencies. And so we got very interested in this idea of, can we, like I said earlier, reorganize the stimulation in time and space? Space being, can we personalize it to each person's brain? I can talk about that in greater detail. And then can we compress these 6-week courses, in this case, into a single day? So that's why Deirdre was able to get well in a day, is because we gave her a whole 6-week course in a day.
You gave her how many sessions?
So that's 10 triple dose sessions. And so it's like 30 total equivalent sessions in a day. And so the FDA cleared 600 pulses of ITBS once a day, 5 days a week for 6 weeks in 2018.
And that was for major depressive disorder?
That was major depressive disorder. We give a triple dose every session, so 1,800 pulses. And so after 10 sessions, you've got the equivalent of 30 sessions worth in that first day. And you do that for 5 days. And so people are getting the dose equivalent of 7.5 months worth of TMS in 5 days. And what we found is, surprising to us, that was this linear, is that, you just pick up remitters as you progress through the days.
What do you mean by remitters?
People who completely lose all of their depressive symptoms to a level that is within the normal range. So they're rating at the same level as somebody who's not depressed. And, we can get people there on an average of 2.6 days, and we're able to do that by personalizing the target and then being able to deliver treatment into that target, a lot of treatment over a short period of time. And so what's useful about that is somebody can be in a really pretty bad state on Monday morning. They can take a week off of vacation, or they may end up being on the inpatient unit or whatever it is, but they can go out, get this done, and get back to work in a time frame that's actually reasonable. And that was really our goal. How do we get people acutely out of these high acuity settings and into a state of wellness quick enough that it doesn't make a major impact on their lives?
Just a quick thanks to one of our sponsors, and we'll be right back to the show. This episode is brought to you by AG1, the daily foundational nutritional supplement that supports whole body health. I do get asked a lot what I would take if I could only take one supplement. And the true answer is invariably AG1. It simply covers a ton of bases. I usually drink it in the mornings and frequently take their travel packs with me on the road. So what is AG1? AG1 is a science-driven formulation of vitamins, probiotics, and whole food sourced nutrients. In a single scoop, AG1 gives you support for the brain, gut, and immune system. So take ownership of your health and try AG1 today. You will get a free 1-year supply of vitamin D and 5 free AG1 travel packs with your first subscription purchase. So learn more, check it out. Go to drinkag1.com/Tim. That's drinkag1, the number 1, drinkag1.com/Tim. Last time, drinkag1.com/Tim. Check it out. I've had a number of friends, and I've certainly heard of many cases where people with certain professions, airline pilots, firefighters, police officers, there are many more, will not report any type of mental health issue because they'll be suspended in a lot of cases or relieved of duty, right? Yep. They'll be forced to take time off. And in a case like this where you have a compressed protocol, there's the possibility of taking PTO or taking a week off and doing this treatment, whereas, like you said, doing it during banker's hours over months is going to be highly visible, right?
Yes.
And until the entire system changes, which is going to take time, if it happens at all, this would be an incredibly attractive alternable protocol if it were to work. So please continue.
Yeah, absolutely. Yeah, no, that's the way that we thought about it, right? Is can we take folks who need to get well quickly? I mean, we had people in conventional TMS courses where, they started, they're in really bad shape, they lose their job halfway through, maybe they get better at the end of it, but it took so long.
Yeah.
And so it's one of these things, if we can compress that up and get them well in a short period of time and get them out of it, it gets people back to their lives and it has a low impact on
I know I'm interrupting a lot, but the threading of this I think is important, so we can sort of foreshadow something that is going to be on the minds of a lot of people, which is, what are the downsides? What are the risks? So my question is, was it easy to get the sort of ethics board approval to compress all of this into a much shorter time frame?
I was able to make a compelling case to the IRB and then eventually to the FDA around safety. And so we give 90% of the resting motor threshold that's depth corrected for atrophy. So if it's an older patient, they have more prefrontal atrophy, then you can increase the intensity based off of that difference in depth of their motor cortex. But essentially what their brain is getting is 90% of the resting motor threshold, which is kind of a calibrated number that's based off of these TMS-induced motor movements. It gives us a sense of how to dose the stimulation.
I'll show a bit of my hand here, which is I've undergone 2 separate weeks with different hardware, different protocols, because I never want to talk about things like this unless I've put myself in the spaceship and been the monkey shot into space, which doesn't mean at this point I am a proselytizer 100% for the treatment, but I find it very compelling, at least for investigation. So to just explain, since I recently went through this, each morning, or certainly on the first morning, but on multiple mornings in my case, they will test your motor threshold, right? And that could be a finger or a hand, it could be a foot, and they'll watch movement really closely, and then based on that, determine the sort of dose that will be delivered throughout the day during these sessions. And in my case, it was once an hour for 10 hours a day.
Yeah, so it's just a way of getting the intensity that you need. And so we know that 90%, meaning submotor threshold, there's never been a TMS-related seizure for that kind of sub-motor threshold intensity. Even, giving multiple sessions a day or whatever it is, there's never been an event like that. It's always been at a higher kind of intensity of the stimulation in the moment, if that makes sense. So the amount of magnetic field that's being put out in proximity to the brain. And so, it seems to be much more related to that than it does the amount of pulses that you receive in a day. And so I was able to lay that out to the various regulatory bodies and show the evidence that that threshold is really the threshold where risk goes up.
It's sort of the magnitude, like the strength of the pulse, not the frequency or the density.
Yeah. It's more about the intensity in this case and less about the density or the amount. So laying that out, it was acceptable, and various parties deemed it to be non-significant risk, and they let us proceed. Now this is FDA, breakthrough status FDA cleared and all the way through all of the regulatory processes. And so it's kind of an on-label approach these days. But, back then I had to make a lot of those arguments. And, knock on wood, we still haven't seen any seizure.
How many people would you say at this point have gone through well-designed accelerated TMS?
It's definitely, I'd say more than 400 or 500 between trials. We have trials where they're ongoing, and I don't know what the clinical outcome of those trials are because I'm blinded to them, but I do know that AEs, we don't have any serious adverse events in the sense we haven't had anybody have a seizure yet. So that's good. What you do see is headache. People will have a headache. It's usually from not everybody, but, a fair percentage of people. And it's mainly related to the coil activating scalp nerves and basically kind of turning the facial musculature on. And that actually goes away over time. So in the long term, you can actually see a reduction in migraine headaches, and you can see a reduction in pain, all that sort of thing. And people actually have an anti-nociceptive effect.
Excuse me?
Anti-pain effect.
Pain.
Yeah.
What was the word you used?
Nociceptive.
Ooh, new one. All right.
Yeah. Yeah. And so you can actually have an anti-pain effect. And the reason why we think that happens is because you actually...
Anti-pain meaning it could help with chronic pain or something like this?
At least acute experimental pain. There are some chronic pain studies. You can see that you release endogenous opioids from stimulation because you can actually use opioid blockers and block the anti-pain effects of TMS.
Wow.
So there's this whole kind of pharmacostimulation thing that people are looking into. A buddy of mine, Joe Taylor, who's at Harvard now, did these studies when he was an MD, PhD, and he was able to actually show that there is this release and then you can kind of block it with co-administration of opiate blocking drugs. But yeah, that's the idea, is that there is some acute potential headache risk, and people can get a little fatigued from this. It's like fatigue, more like you ran a marathon instead of like depression-related fatigue, just from kind of being there all week.
Look, N of one here, but seems, I spent a lot of time talking to folks, as you know, kind of my job. My experience was headache for sure. I was hesitant to take any type of Tylenol or medication for that just because, and this is, again, as a naive layperson, but I was like, well, like if you do take NSAIDs, if you're doing, say, weight training, that can inhibit some of the adaptive response. I'm not sure we fully understand what the hell's going on here. So I'm just going to deal with the headache. Sure. It was tolerable. I mean, you could feel it. The fatigue was the fatigue that you might feel if you were cramming for your final exams every day.
Yep.
It was not the fatigue of apathy and anhedonia, like the difficulty or impossibility of finding joy in the things you would normally find joy with. Like that type of fatigue is characteristically at least very different. It's more like, you just crammed for 20 hours to try to nail your finals because you didn't prepare, and you're going to do that every day.
Yeah,
that was the feeling. Question for you then. We're going to get to the results. I want you to discuss the sort of results of Saint. But I think before we do that, it's important to maybe describe this patient population. Is it fair to say that you're seeing, it would be an exaggeration maybe to say the worst of the worst, but you're dealing with patients who have had multiple failed interventions. So it seems like that's important to kind of keep in mind if that is true.
Yeah. And so in our randomized control trial, people had an average of 9 years of the current episode. So they were depressed for 9 years on average straight before they came into our trial. They had 5 ± 2 med failures, and they had a lifetime load of depression of about 25 years. So these were folks who'd been depressed with multiple episodes or very long episodes. And they tried a lot of meds to get out of those episodes. These are not mild cases, right? These are folks who've kind of been through it for a long time. And interestingly, that's going back to the study that we talked about earlier with the flipping of the signal. That flipping of the signal was correlated with higher MADRS scores. And so the more...
MADRS is the assessment.
Higher depression scores. And so the higher your depression rating, the higher likelihood you are to have that signal from the data that we collected. And that's what we've seen, right?
Got it. And the switching, just to tie it back to what we were talking about, is that sort of having the wrong lead domino, or like
exactly.
you have a car where you're trying to start the diesel car without heating the coil first.
Yeah, that's right.
Type of situation. Yeah.
Yeah. So it's that directionality. And so that's what we've seen. Folks that are at that kind of more end stage sort of depression seem to be more responsive to this. I think that's because in those cases, you're really correcting this pretty dense brain signaling problem if that PNAS work replicates. And what we've also seen is folks that do really well with dorsolateral, at least, are folks who have a pretty impaired tension. And so they actually score up on the concentration item of the depression scales. And so that was something we observed earlier on, that if you're saying you can't read a book anymore, you can't really follow a recipe book to cook your favorite meal or whatever because you just can't attend to it, then your likelihood of getting better from this is higher. Whereas folks that are more on the kind of obsessive, depressive side of things that don't complain as much about cognitive problems and concentration problems, but more about they're just ruminating and kind of obsessing on things, we've found that inhibiting the right frontal pole orbitofrontal cortex, so stimulating here, and we have OCD trials to do that, is pretty effective at shutting that down. So it's more of a shutting down than a turning up sort of intervention. So some of it's actually like where the illness intersects with the brain anatomy, intersects with like the symptomatic presentation. to try to derive the best spot to stimulate for those folks. And we have some early studies now where we're trying to use brain imaging to actually sort folks into buckets neurally to figure out which target makes sense for their symptomatic presentation.
Based on their personalized fMRI scans?
Yeah.
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 So I think this would be a good point, and we'll mention this again at the end, but maybe you could mention any open trials, or if people would like to consider enrolling, or they know someone who might want to become subject in a study. Is there anything you'd like to mention?
So we have a number of trials that are ongoing at the Stanford Brain Stimulation Lab. So it's bsl.stanford.edu. And you can go on the website, and then there's like a screening portal, and people can go on and fill out their information. And essentially, we have trials for anhedonic depression. We have trials for standard severe treatment-resistant depression, obsessive-compulsive disorder, borderline personality disorder, patients who also have depression, bipolar depression, and other pilots, some addiction work that my collaborators are working on. And so folks have, that range of symptomatology. Happy to have folks come through and screen. And it's all free, which is nice. So it's all basically funded through these trials. And we're excited to bring people in and see if it makes sense for them to work with us on this. And it's a couple of week commitment.
What did the results, or what have the results looked like with Saint, or slight permutations of that? And how do they compare to, let's just say, more conventional treatments for these same conditions?
So in our original pilot study, 90% of people experienced remission at the post.
90%.
90%, yep. In the randomized controlled trial, it was 79% of people transited through remission at some point in the 4-week follow-up. What's interesting is it's not all at the same time point. So if you look at time point by time point, it's like in the 50 to 60% range. The reason for that is because there's this, colleagues of mine at Cornell, Connor Liston and others have replicated this finding that there's a subpopulation of patients that actually has a slower time to remission. And we've seen this too. Folks will lose their suicidal ideation and actually peak their antidepressant effect at 1 month. It's usually in older adults. And that's what we've seen is basically it's only in 50-year-olds and above. We haven't seen that.
That sort of delayed remission?
That delayed remission, yeah. But if you're putting together 22 to 80-year-olds, you're going to have some of these folks. But what's interesting is TMS is also a probe of the system. If you kind of ignore the kind of normal rules of how to define remission and you just ask the question of who crosses through, 79% of our active group crossed through, 13% of our control group crossed through. And that tells you something, I think, about the neuroanatomy, that probably something in the 70% of folks have this dorsolateral cingulate problem. And then that was a version of that thinking was seen in our PNAS signaling paper too. About 70% of those folks had the flip in the signal. And so, my suspicion is that there's a subpopulation of people who don't have that, who have some other diagnosis. It probably looks a lot like depression, but is probably a different neuroanatomy. And we've seen this sort of phenomenon happen in medicine before. We used to cluster all the Parkinsonism together. So there's lots of reasons that Parkinsonism, some of those reasons are idiopathic Parkinson's disease in the classic sense. The way
What does idiopathic mean?
Just that it's kind of this spontaneous happening of Parkinson's disease that's the core Parkinson's syndrome that we think about, Michael J. Fox and others. And then you've got other things that look like it, progressive supranuclear palsy, Lewy body dementia, drug-related Parkinsonism. And so we used to kind of lump...
Parallel to your diabetes presentation earlier.
Yeah, exactly. So we forever lumped all these folks together, and it really took the UK Brain Bank and being able to, in that case for Parkinson's, link Parkinson's pathology to symptomatic presentation.
What is the UK Brain Bank? And I've never heard of this.
Yeah, so it's like a brain there's lots of brain banks or brain donation entities.
Physical brains, or are we talking about scans?
Physical brains after death, post-mortem donations. So there's a lot of ways you can donate. If you have a neuropsych disease, you can donate your brain to science. And so a lot of Parkinson's patients donated their brains to this brain bank to try to understand what it is. And what they found was with a deep clinical phenotyping before death. So then you had this kind of deep phenotyping and then...
Sorry, what do you mean by deep phenotyping?
Like a deep kind of understanding of the symptomatology, right? So So basically, does their tremor happen on one side or both sides at the same time?
How do things present?
How do things present?
In an observable way.
That's right. Exactly.
In the same way, just folks, so you have like genotype, phenotype, right? Like, so this would be a similar idea. Okay.
Yeah. So basically what they found was clinically, people that have the kind of standard Parkinson's disease typically tend to have a presentation of unilateral onset illness, right? Where one side of the body or the other is much worse from a Parkinsonian standpoint than the other. And it's actually very common for people with Parkinson's to present where if it's a leg onset Parkinson's, their foot's dragging or tremor just in one hand. And that's actually what you would expect from normal Parkinson's. If it's like really symmetric, it's less likely to be that. It's more likely to be something else. And they figured that out from essentially the brain biology informing that, being able to link up substantia nigra problems they found on autopsy with symptoms. And so I think we're at the beginning of an era in psychiatry to be able to do the same sort of thing, to take what's lumped together as depression or anxiety or whatnot, and to be able to parse it into a lot of different, what we call biotypes, or people think about as endophenotypes or whatever, these specific kind of flavors of that symptomatology, some linked with a very specific brain physiology or brain functional neuroanatomy, such that you can say that this depression type 1 needs this treatment, depression type 2 needs this treatment, and so on and so forth. And so that's really, from my vantage point, the future, right, is being able to really at an N of 1 level, at a single patient level, be able to figure out something about their brain and then help to prescribe what the next step is for them. And, if we can do that, we can also cut time, right? Because we can go straight to the effective treatment for people and cut all the time around diagnosis. I mean, and
it's not just time, it's risk, right? I mean, in a lot of these cases.
Absolutely. It's risk from potentially the wrong treatment. It's also risk from waiting.
Cost, potentially, also, right?
It's also cost, yeah. So as you know, right, like there's a period of time where the diagnosis is uncertain, and then there's a period of time where the treatment is uncertain. So for bipolar depression, the average length of time it takes to diagnose somebody with bipolar disorder from a depressive episode onset, so they come in with depression, and depression's their primary, presentation, 7 years till you get them.
Jeez.
Right?
It's wild.
Right? And then that's just to get to that point. Now you're in the right realm of medications or whatever. Now you're talking about in year 7, you're having to spend whatever it is, like 3, 5, 7 more years trying to find a solution. So you could go from being 25 years old and, having this be your first depressive episode, and you're still trying to figure out what you're going to do about it at 40. And you see these patients.
I'm just imagining you're like reaching into a dark closet and there's what you think is a screw head, and you're just trying different tools, but you're not allowed to touch the screw head.
That's it.
Versus like, let's flip on the light, take a photograph,
yeah,
and then go find the appropriate tool for the job. Just a couple of follow-ups. The numbers that you were mentioning, right? The remission rates, the people who pass through, so to speak.
Yeah.
How does that compare to like frontline conventional treatments right now?
Oral antidepressants so there's a study called STAR-D. It's been an interesting year for STAR-D in the sense that some people have reanalyzed that data, and there's open questions about what the percentages are as far as what percentage of people make it to, a remitted state after going through this algorithm. But essentially STAR-D started with a pretty low side effect burden oral antidepressants, citalopram, and then kind of transited through, higher risks, sort of like SNRIs and...
What's the trade name for escitalopram? What do you know? People would know that is?
Lexapro.
Lexapro. Got it. Okay.
Yeah, and citalopram, Celexa. So those drugs, and then you go to like SNRIs, like Effexor, venlafaxine, and then into like the tricyclics and the monoamine oxidase inhibitors. And so people would go through this algorithm, and then they'd pop out on the other end after 5 or 6 or 7 different treatments, and then they'd ask the question of, after people go through all of this, what's their remission rate? So that number's kind of been called into question. But essentially, when you get into like Med 4, which is roughly where insurance used to start to pay for conventional TMS would beat that pretty well, like almost double compared to, you're talking about lithium or thyroid hormone, things like that when you start getting into that step. and conventional TMS would beat that. When you get to those kind of next, even more severe steps, you start to lose efficacy with conventional TMS. So you go from like a remission rate of around 30% with conventional TMS down to about 16% when you get into the higher treatment resistance levels. That's the levels that we ran our trials on, which really that where people normally get about 16% remission with conventional TMS. That's where we were seeing those numbers.
Could you just repeat those numbers? Were you seeing what numbers?
In our open label trial, 90%. In our randomized controlled trial, depending upon how you look at it, it's in like the 50, 60% at each time point, or 79% if you're asking, did people transit through remission at any point?
Versus 16%.
Versus
Not that,
16.
and this wasn't like a head-to-head
It's not a head-to-head
thing, but just so people have some means of comparison. And in terms of pharmaceutical interventions at that point?
Very low. I mean, you're talking about sub 10% efficacy. This is around where electroconvulsive therapy is thought about, right? This kind of therapeutic seizure thing we were talking about earlier. That's got about a 48% remission rate, but it's not fast either. And you definitely can't work the day you get it. And there's this autobiographical memory thing. So you're talking about like conventional TMS, like a 1 to 2 month commitment, and then quite a bit of risk for side effects there. You've got ketamine, which produces about a 30% spot remission rate with a single infusion, and that goes up as you administer more ketamine treatments, with the IV ketamine forms. But as you go from a single infusion to, what they did in this New England Journal paper that was published a couple of months ago, like, 6 treatments over a couple of weeks, it starts to accumulate more time. And so we're able to, from my standpoint, we're able to get the most bang for your buck the quickest and with the least kind of interruption in, I think, people's ability to do stuff during that time. But there are other things, ketamine, psilocybin, other psychedelic drugs that I think you've thought about and talked about on this show before that are also coming over the next couple of years.
Few follow-up comments and questions. So you mentioned a number of things, borderline personality disorder, bipolar as 2 examples. Part of the reason that I'm so interested in neuromodulation right now, accelerated TMS in particular, although I'm also interested in other things that I know less about, like focused ultrasound and so on, which we might get into if we have time, is that many of the conditions that would be screened out, that would be exclusionary criteria in, say, a psychedelic-assisted psychotherapy trial, are eligible for this type of treatment, which is incredibly interesting. There are people also who might have something that is more common, extreme hypertension, some type of like ocular issue, where physiologically psilocybin shouldn't technically pose a risk, but if they have a lot of panic, rapid heart rate, et cetera, there might be complications, right? Elderly patients, et cetera. So part of the reason this entire realm of treatment possibilities with neuromodulation is interesting is because these tools could be available to people who would not be good candidates for some of these other things that you're mentioning. What I'd love to ask you about, because this has been one of the questions that's just stuck in my head, is the topic of delayed remission. So having these patients, I can't remember the number. I was looking at some of the charts. Maybe it was 3 or 4 people out of N of 16. I can't recall.
Yeah, that's right.
Okay, there we go. Who had this remission at like week 4 or something like that. How do you explain this, and why is it older patients, or does it seem to be older patients? And how do you relate it to a few things, right? So in the case of, say, SSRIs, some folks also have this, like a lot of people, like delayed onset of benefits, right?
Yeah.
And then you have ketamine. This is going to be a bit of a sloppy question, but I'm sure you can clean it up for me. Then you have ketamine, which is very rapid acting. And I have heard, I do not have the credibility or the means of parsing all of this. And like, okay, well, ketamine acts directly on NMDA receptors. Seems like maybe SSRIs do that, but in a very indirect way. And that explains the delayed benefits in some patients. Don't know if that's true or not. Don't know if I'm even wording that correctly. How do you kind of tie this to, or not, the delayed remission? Because I'm just like, how does that even work, right? I'm like, okay, if you put a drug in someone's head and it triggers a cascade, or maybe it triggers some type of exceptional neuroplasticity that then shows the fruits of that at weeks, whatever, 2, 3, 4, okay. But I just cannot figure out, I haven't been able to figure out like a plausible mechanism for the accelerated TMS and that delayed remission. How do you think about that? Like, even if it's speculation.
Yeah, it would be speculation. But I think, so we've only seen in older adults, and we know that the brain plasticity in older adults goes down as a generality, and there are lots of metrics about why folks think that. And you're, as you talked about earlier, really, it's cramming for a test. You're actually sending a memory signal into the brain. So the stimulation pattern that you're sending into the brain, this kind of Morse code, is really a turn on, stay on, remember to stay on memory signal that's going into the brain. And you're just basically taking the hippocampus, the part of the brain that's involved in memory, and like that signaling that comes out of there, and you're playing that back through the prefrontal cortex in a way to try to tell the prefrontal cortex to turn on and remember to stay on. And I think part of what's going on is because that older brain is a little less likely to have flexibility, plasticity, it takes some time for the signal to kind of fully lay its tracks into the brain. We don't have any sort of biology to kind of back that up yet. But what we're doing right now, and we haven't analyzed this data yet, is we're actually scanning people every single day. And we're scanning people multiple times out to the month. So NIH funded one of those.
By scanning, you mean fMRI?
fMRI scanning, yeah. So we're actually getting like 10 scans spread out over.
It's a lot of coffin time.
It's a lot, yeah. We, people have been very cool about this. And so with that, we think that we're going to be able to potentially spell some of this out, right? Like, why are these delayed remitters happening? But my suspicion is that it's probably a plasticity related issue. Interestingly, ketamine and TMS may have more in common with each other than one would initially think, right? Like, a lot of the TMS effects are probably in part glutamate related, is ketamine. And then, as we talked about earlier, there's an endogenous opioid release from TMS. We've done some work with opioid related mechanisms in ketamine. And so there's probably a confluence of not one neurotransmitter system, but like an orchestra of neurotransmitter systems that are being affected across these interventions. And it's my suspicion that that's probably what needs to happen in order for these treatments to be effective. And our old views on, this kind of chemical imbalance sort of 1990s view of like one neurotransmitter receptor sort of problem in the brain is way too simplistic, and that it's probably a lot more complicated, as one would imagine, a lot more complicated than that.
Outside of accelerated TMS, if you're looking out, say, over the next 5 years, for rapid-acting, potentially durable antidepressant effects, what other tools or molecules or treatments are most interesting to you?
We have a paper coming out soon in Nature Medicine on looking at Ibogaine as a potential treatment for, in this case, for military traumatic brain injury, but a lot of these folks had depression, generalized anxiety disorder, and PTSD. And so it was that was another interesting story. So I was approached back in 2018 by a senior professor at Stanford, who was tapped by some folks to kind of find somebody who'd be willing to partner with a nonprofit called Vets at the time, who were sending, and I think you've interacted with Amber and Marcus Capone a little bit.
Yeah, I interviewed Rick Perry and Rick Doblin 2 years ago at their Veterans Day fundraiser.
Yeah, I was there. I remember that was an interesting one. Yeah. We partnered up with them, and I had to, again, go to the Stanford IRB and ask them for another edgy. And, you have to give the Stanford IRB credit.
Could you just spell out IRB?
Oh, sorry. Institutional Review Board. It's the entity that reviews all research protocols at institutions. And so this is the kind of governing body that's in place, that's been around for about 100 years, that essentially is a non-conflicted, uninvolved group of senior professors that look at your proposed research and then determine if it's ethical and safe and answering the questions that you think you're going to answer. And so just like going to them to talk through doing accelerated TMS and saying, we were able to talk to them about doing a study where people would come to Stanford and the IRB knowingly agrees to them then going down to Mexico to take an illegal in the U.S. root bark extract that's been utilized for millennia in the country of Gabon and related areas in Central West Africa. And as you can imagine, this was not a quick turnaround, nor should it have been for the IRB, in the sense that I had to convince them this was science worth doing.
At that time, though, is it fair to say you're the TMS guy, or was it like in the air that you also had an interest in exploring something like an iboga or an ibogaine?
People knew that I was very open-minded to things. And I'm a pragmatist, right? I mean, for me, like, the patient's the most important thing. I have this view of psychiatry that it's going to look like inpatient cardiology in 20 years, where we're going to use drugs, we're going to use devices, we're going to be able to figure out what the best thing is for that patient. To your point, some of these things are good for different problems. And so I think that was known, that I was open to that. We'd just been running this ketamine mechanism trial. And so I was tapped to look at this, and a couple other people too. And I found out later they'd gone to like a lot of people. And apparently I was like the only person that was willing to do this trial. Like, I felt kind of special back then, and then like later realized that like,
oh, wait a second, I was on the Bachelorette and I didn't even realize.
Yeah, I was on the Bachelorette and I didn't realize it. So essentially, yeah, and the Bachelorette was a tricky one, and so we ended up reluctantly agreeing to this, and admittedly, like, I almost pulled out a couple of times because ibogaine has this street knowledge and academic knowledge that it has a death risk, right? It has a roughly 1 in 300 risk of death from torsades de pointe, this fatal arrhythmia that can happen with certain cardiac acting drugs. And it works through this, what they call HRG potassium channel. Other things do this, or like FDA cleared cancer drugs and arrhythmia drugs that'll do it too. So it's not, in context, it's like something that happens with lots of different drugs that we use. But I think there was somewhat of a stigma and a bias around particularly an addiction drug. And so folks had been trying to get this through the FDA and NIH and whatnot in the 90s, Howard Lotsoff and others. And it was a very complicated drug. And I'd known about it since residency. I'd read about it. I thought that, it's like, wow, this is like the most promising anti-addiction drug on the planet. But I'd thought it was completely unstudyable. And I kind of like kept doing my other stuff. And then
at that point, how did you come across ibogaine? Where did you find it?
In 2012, 2010, I think.
Would this been like early Deborah Mash stuff, or?
No. I come across this book, Breaking Open the Head by Daniel Pinchbeck. Yeah. Uh-huh. And he, he's a big, I think he wrote for the New Yorker or something. And I was stuck. I was like going kite surfing in South America, and I was stuck in the San Salvador airport. And there was like 5 English-speaking books or something, and I picked this book up in the airport, like stuck.
That was in the San Salvador airport?
Yeah.
Wow.
Yeah,
okay.
Randomly, right? And so I got a hold of this book and read it waiting on my flight, which was like 8 hours delayed to get to Peru. And so essentially, he just like lays the whole thing out. It was very interesting. He talks about his own personal experience of it. And I read a lot about it. And there was some work that folks like Ken Alper and others had published on the kind of case report level outcomes, but then also the cardiac problems. So then I figured it was kind of unstudyable. And then in 2018, I was approached and was asked to do this trial. And so we went to the IRB, spent a year back and forth. And like right when they were they approved it, COVID hit. So we were actually supposed to start right when COVID happened, and it paused the whole thing. And then, it took a while to get it back online, but it was actually the quickest recruiting study I've ever run. We got 30 people done in like 8 months.
Now, is that because of the sort of category of like potential death of despair? I mean, is it because of the patient population? Were you dealing with addicts?
So the patient population was, and that was the unique part about this, it was veterans with traumatic brain injury, some of which were alcohol use disorders. So, what we used to call alcoholism. More than a third, like I think 13 or 14 people out of the 30. But everybody had TBI. A lot of them, most of them had depression, most of them had PTSD. And so, we're running this trial. I was put like my best neuropsychology postdoc on it and a couple other superstars, and it was running in the background. And I was like, we'll get this into a pretty good journal or whatever, thinking we'd see some people get better, some not, whatever. And I remember I was asked to give a talk about it at a very prestigious university, and asked the postdocs, we just wrapped up the immediate post, and asked the postdocs to put the data together, and we'd have data to present for them. And they showed me like the clinical outcomes, and I was like completely blown away. It was way better than I think we anticipated. Like, very consistent improvements in like basically everybody. Some people would lose it, before the month, but most people held it, and they're holding it out to a year now. And I was floored. I actually told them to delete all the code and start the analysis over because they had to have done something wrong in the math, which is always fun. The postdoc always, they kind of say yes and look at you. You just ruined my weekend. And so we did it again, and it was the same exact findings. So I was wrong, they were right. They had done it right the first time. Yeah, and essentially really, really striking. And by the time this will come out, Nature Medicine will have published this.
Somewhat prestigious.
Yeah, somewhat, top 5 biomedical journals in the world. And
it's like being nominated for Best Picture at the Academy Awards. I mean, scientifically speaking, right? It's up there. It's up there.
It's a nice deal. And it was very surprising that for me that they were going to be open to publishing an open label paper, which, historically you're going to publish in that kind of a journal, like a randomized trial.
So just for clarity's sake for folks listening, so open label means no placebo control. And also, to just rewind for a second, I want to mention to people that for accelerated TMS, how do you know it's not placebo effect? You mentioned the control group, but that's a sham treatment, right? Like you're basically, people feel like they're getting a treatment, but they're not actually getting the proper treatment.
Yeah, in that case, you want to ask a blind guess, and that's actually been a big, so I was going to get into here, a big problem with a lot of the psychedelic trials, and why there's a lot of criticism for a lot of the psychedelic trials is that they kind of know that the blind guess is going to be highly skewed. So there's one trial where they did psilocybin for alcohol use disorder. I think it was like 99% correct blind guess rating. So the p-value is highly significant. In our Saints studies, to my great surprise, our blind guess was chance.
Huh. Could you explain what do you mean by blind guess? These are the experimenters trying to guess who is in which
This is
group?
The patients trying to guess what they got.
I see.
Yeah. So Mr. Smith, you just wrapped up your treatment. Which treatment did you get, active or sham? What's your confidence?
Got it.
In what you got? And so what we found, which is really interesting for Saint, was that I didn't know what people got, but I talked to some of these people and I heard some of this. So it was really interesting. Patients who'd gotten totally better, and they'd say things like, yeah, I just got lucky with placebo this time, and they ended up getting active. And then the folks that didn't get any better, that they got sham, would say things like, I'm not even good enough to respond to the active treatment. So it was confusing enough for them where they were making the wrong guess 50% of the time, which is what you're looking for, is about 50% error rate. And it's a coin toss.
Sidebar on that. I know this is kind of staccato the way that I'm trying to hold this conversation, but having gone through 2 weeks, different hardware, different practitioners, et cetera, and having had a lot of conversations with technicians and so on, it also seems like for some people, it takes a while for their narrative to catch up with the hardware upgrade, right? In the sense that they say, well, maybe I got lucky, or maybe I don't really feel that much. And yet their assessments are improving, and or their significant others see dramatic changes, right?
And that's true. That's not specifically a TMS effect or SANE effect or accelerated TMS effect. That's true, I think, for a lot of treatments. You see that. I mean, I've had calls in since our data's been out on Ibogaine where I've had people call me and say, hey, Mr. or Mrs. So-and-so, they look amazing, and they don't think they're any better, and so I think you can see it across the board, psychedelics, neuromod. There's a certain problem called alexithymia in about 25% of people with treatment-resistant depression.
Alexithymia.
Yeah, and so A meaning without, lex meaning the ability to describe, thymia, mood, and so they can't really describe their mood, right? And so they have an inability to accurately rate their mood, and the way you know that is
alexithymia. I'm going to use that at a fancy cocktail party. So, Tim, how you doing? Sorry, got alexithymia. Oh, sorry. You may better know that as difficulty to describe mood.
Yeah, that's right. Sorry, I'll try to back off on the medical jargon.
No, I like it. I'm learning all sorts of words.
Yeah, it's an interesting term, and it's an interesting phenomenon. And you see this in psychiatric conditions. If you ask them very specific questions, like, well, when's the last time you've been sad or thought about anything negative? Oh, it's been a week or two. Are you depressed? Yes. Well, why do you know that? I don't know. They just don't know.
It's also a self-reporting problem too, I think, in some cases, right? It's if you ask someone how many calories did you eat yesterday, most people would be off by 30 to 60% or something, right?
Yeah, that's right. And I think what the remedy for that is that you have a clinician rater, and the clinician rater asks these really, really pointed, very detailed questions, and then the patient's able to answer. And then it's like a formula to calculate what that mood rating is in that case. And sometimes it's just off from what their perception is, their kind of meta perception of the whole thing. But when you get down to the brass tacks, they're answering right. And so we've seen that. And that's been true across these problems. And there's ways of constructing trials to deal with that. But yeah, we've seen that with psychedelics as well. So we went after military TBI.
And these were all special operations?
Mm-hmm. Yeah, they were basically all Army Rangers, Navy SEAL, former Army Rangers, former Navy SEALs. And there's been a big cohort of these folks that have gone down. I mean, some people in Congress have gone down and done this and have spoken about it publicly. I mean, it's this National Defense Authorization Act, the NDAA, I think is just, went through the Senate and the House, both approved it, I think yesterday, and it's going to Biden. And so, to earmark money for Ibogaine for trials, which is pretty cool. So the military community and some of the government is pretty aware that this is a possibility. There's been a lot of advocacy that Amber and Marcus have been involved in. And my hope is that coming out of a journal like Nature Medicine that really kind of validates what we were seeing and puts some context to what we observed and what we found in our study will help to spur more funding and more focus. And I think the kind of veteran psychedelic angle is an important one, for like a lot of ethical, moral reasons, and and a lot of.
They also have like a political immunity bracelet, right? So
That's right.
It's a very
that one
important subpopulation, and it's very fortunate that it aligns with sort of driving forward the research around these therapeutic tools.
Yeah, it's super cool to work with those guys.
And this was a monotherapy in the sense that it was just Ibogaine. I know that at least in many places in Mexico, they sometimes combine it. Well, they don't combine it, but they sequence it with 5-MeO-DMT at the tail end. Was this Ibogaine alone?
Yeah, so it was Ibogaine alone, and then we had folks come back later to do the 5-MeO outside of this kind of month follow-up period. But the data that we're publishing in Nature Medicine is just the Ibogaine effect. It was tricky because that kind of divorced those two together, because that's what's been going on, as you know, in Mexico quite a bit. So all of the acute out to the 1 month effects are all direct Ibogaine effects. And it's, super cool. And the thing that I found really interesting about this drug is that it produces what I think is probably the most stereotyped trip, if you want to call it, or, the psychological phenomenon that happens alongside the drug effects. And so people will describe this earlier life autobiographical replaying of emotionally salient memories that are epoched in time.
Some people would call life review, right?
Life review or slideshow. Yeah, exactly. And so, it's interesting. Everybody's kind of got a different version of what the slideshow ends up playing out to be like for them. And so some people would say, I found myself in this room and it was like my TV from childhood, and all of a sudden it was playing all these things, or I found myself in a hall of mirrors and it was playing all these things. So like the context can be very different, and the mind seems to shape that, but the actual replay seems to be pretty stereotyped.
Stereotype meaning like it's a pattern that repeats, or it's just like a common characteristic.
It's a common characteristic, and it's closed eye only. It's not open eyes. It's not, for a lot of people, the Ibogaine experience is kind of really around this part, this kind of replay part that happens. And, from what I have heard, there's kind of a cathartic reevaluation of these memories. And interestingly, an ability to not only have insights into your own reasons, which may have been good or bad for feeling or behaving or doing whatever it was, but also reasons for, they have some insight into the reasons for the other, which to me is like the hardest thing to explain.
You say it one more time.
When people have this slideshow or life review, they seem to have it as a third-party person in the experience. Like, what is this, Christmas Carol Scrooge or whatever, when they go back in life and you see like,
you become the observer of your own past experience.
Right? It's kind of like that. Like Scrooge goes back and sees himself as a kid. He sees himself as like when he broke up with his significant, all that stuff. It's almost like that. Like you're having a similar sort of thing where I've used the analogy of Tom Cruise in the Minority Report, where you're able to go back and see these events. And what's so fascinating, and why I've said, and I'll continue to say, I think this is the most sophisticated drug on the planet, is that I think that there's nothing else that can seem to do this, right? Where you have these experiences where you're able to hold this neutral place, and you're able to have this sense of where you were and why you did what you did, and you have this sense of the other, and you're able to, I don't know, intuit. I don't know what that is. You somehow stored it at the time, and you weren't able to fully access it, and you're able to access it, whatever that is. Being able to forgive or to forget or to understand this person's position as well as your own, and then seemingly like unlock the lock on both sides and then dissolve the problem. And people say they kind of would work through all of this. And, there's one veteran, would say, well, I went through all this military stuff, and at the back of the room, it was my early childhood trauma, And so this idea that at the core of it, for a lot of this, ends up being a childhood trauma thing that's kind of buried below all of it, and really being able to actually both access that in a way that you can understand that in many cases the traumatizer was themselves traumatized, and that it's just a pattern of trauma, and the ability to kind of resolve it by understanding at this kind of, more meta empathic viewpoint. And so that's where I think the tool is really going to be important, is this ability to have what seems to be a pretty profound neurotrophic effect. We were able to see disability improvements from traumatic brain injury, but also this pretty pronounced kind of cathartic re-evaluation, reconsolidation of past life problematic memories.
All right. As I want to do, let me hop in with just a few comments that we can bounce around if we want, and then a whole bunch of questions. So the first comment is, with the special operations vets who are friends of mine, what I've observed may be similar to what you're describing. That is, part of what has contributed to them being extremely high performers in these high stress environments is their ability to tightly compartmentalize, which they developed when they were traumatized as kids. Super high overlap, like incredibly high overlap. Of course, there are many other factors that contribute to them being like the one person out of 10,000 who doesn't get washed out of training, right? Being that unbreakable in a sense. But with those friends, and look, it's a tiny sample size, but of those friends, like I wouldn't say any of them would claim to have PTSD or moral injury, like a feeling of having done the wrong thing. But the TBI, and this is where I want to lead into a question, which is not to negate the fact that a lot of people could have, of course, meet the diagnoses for complex PTSD and so on. With the TBI, what makes ibogaine different from some of these other psychedelics? And I want to say one maybe place to explore would be glial cells. Am I making this up?
Glial-derived neurotrophic factor, yeah.
Glial-derived neurotrophic factor, there we go. What makes it different in terms of mechanisms of action, therapeutic effect, compared to some molecules people might be more familiar with, psilocybin or otherwise?
The classic psychedelics like psilocybin, as you know, primarily affect the 5-HT2A receptors, right? So they're 5-HT2A agonists. They produce these kind of classic psychedelic experiences largely from that receptor. You can selectively knock out 5-HT2A receptors. You can knock out the psychedelic effect. So we've largely thought about kind of this class of psychedelics in that way. Ibogaine's a noninvasive, so it produces a dreamlike state. Some people call it an atypical psychedelic. We've elected to kind of use this noninvasive term because I think it more accurately reflects what's going on in the trip and in the way of kind of perceiving what it is. It does have some 5-HT2A action, but that's probably the minority of the effect. It affects a broad range of other receptor systems. So like salvia, for instance, is a kappa agonist, right? And so there's kappa mu effects, there's NMDA effects. With ibogaine, there's SERT effects, so serotonin effects. And then there's this upregulation of BDNF, brain-derived neurotrophic factor, and GDNF, glial-derived neurotrophic factor. And both of those are, profound neurotrophic factors for plasticity in the brain. The problem is this has been, psychedelics were thought of as relatively obscure 15, 20 years ago to study. Obviously, that's changed now, but ibogaine is extremely obscure, right? So there were a handful of studies that were performed published in good journals over time, but it's very limited in the data that we have so far. So it's hard to give you some sort of definitive answer. What I can tell you is that there was a paper published, I think 15 or 20 years ago where they took mice and they got them to self-administer alcohol. So that's kind of like a way of like an addiction model or whatever, alcohol self-administration or sucrose self-administration, sugar self-administration. It's like a way of kind of you can put cocaine in the water and get
modeling
mice to,
addiction.
Yeah, exactly. And so if you give a mouse Ibogaine, you can get them to stop self-administering alcohol. It's interesting. We saw that in humans that stopped drinking as well in our study. Or you can, in this case, you could actually drill a small hole in the mouse's brain. You can inject GDNF directly into the ventral tegmental area, the area that produces dopamine for the kind of more of the pleasure-seeking part of the brain. And it emulated the same effect as the Ibogaine, right? So this GDNF effect in the dopamine system, at least. And GDNF is thought to regulate dopamine neurons. And so, I think that that's probably at least a pretty strong part of it and what makes it so unique. But I always tell people, like, when I'm talking about this Ibogaine stuff, like, if we gave one of the big pharma companies $100 billion and said, don't just resynthesize Ibogaine, but make a drug that works like Ibogaine. I think even some of the classic psychedelics, but really specifically Ibogaine, I think they'd have a hard time doing it because we don't have the neuroscience to understand what's going on there. And I think it's because it's not a one receptor.
It's not super clean in that way, right?
Yeah.
It's like promiscuous.
People use that term dirty drug. I think
It has the wrong connotation, but
yeah.
I mean, like LSD is pretty kind of promiscuous on the.
Yeah, I think promiscuous. I like to think about
complex,
it like
sophisticated.
I like to think about it like a symphony,
There we go. Yeah.
right? Like
Yeah,
that you're interacting with these neurotransmitter systems in proportions in such a way that it produces this effect. My suspicion is that it's probably more sophisticated than we want to attribute to. I mean, maybe not you, but like the scientific community wants to attribute to nature being able to pull off, But it's this idea that maybe somehow we have this drug that just happens to work the way it works because it's able to interact with these systems in pretty important ratios or pretty important kind of simultaneous effects. And that's really what's driving it. And that's the part I'm saying it's going to be hard to reproduce. I mean, obviously, Sasha Shulgin and others were able to emulate similar sort of 5-HT2A effects, but I don't even think he was able to produce an Ibogaine-like multi-receptor sort of symphony like this. There hasn't really been another drug like it in this way. And so trying to think about what that is and how to study it, it's going to take a new wave of neuroscience tools to be able to capture all the effects, in real time.
I have a symphony of follow-up questions.
Okay.
And so I'll give you can choose. This is dealer's choice. You're the dealer.
Okay.
So we could go with, and we will get to all these, but improving the safety profile of Ibogaine, which I should also say, like, I've had people reach out to me, which is always can be very uncomfortable for me, but like friend of a very close friend. And in this particular case, someone's sister was a heroin addict who is now homeless, acting as a prostitute, like living under an overpass. And the reason I bring up that level of detail is that for a lot of interventions, in this case, Ibogaine, at that point, the cardiac risk or some of the risks were known. And there's a question of, is this risky? And the follow-up is compared to what? And in this particular conversation, it was, well, she could die tomorrow from an OD or this and the other thing. So I'm just kind of setting the table with that. But improving the safety profile, right, is one question. Another, because you mentioned the cessation of or the minimizing of the AUD, right? So like people stopping drinking.
Yep.
We were also talking before recording, people stopping drinking caffeine, I guess, or coffee.
Yeah, we
right?
saw that. Yep.
Okay. Unexpected, presumably.
Yeah.
And so my question there, which I sort of seeded, because I mentioned I would want to talk about this, it's like any overlap in terms of mechanism, or how does this compare to something like semaglutide, right? Like an Ozempic or some of the newer gen, I think it's Mounjaro, maybe getting that wrong. And then the last one, and I've been wanting to ask somebody about this. You mentioned 5-HT2A. It seems like some psychedelics exert effects also on 5-HT2B receptors. And if I'm not mistaken, there's some data to suggest that can continued stimulation, like agonism of that B, can lead to some type of cardiac complication as well, like some type of ventricular hypertrophy.
Heart
Valves, exactly.
Yep.
So the question there is, do you think that microdosing, for instance, which has become all the rage, could that potentially have long-term negative cardiac effects?
The FDA guidance document for psychedelics that they released actually like on the last day of the psychedelic science meeting, which was really interesting, is specifically has a section about this issue of cardiac valvular problems, particularly from these more classic psychedelics. The problem with ibogaine is different, right? The problem with ibogaine is that it interacts with hERG potassium channel. And there are a number of groups, folks at Columbia, folks at UC Davis, who have looked at this, and their solution is to modify the molecule and to affect it in such a way that it no longer interacts with hERG.
Do you mean like noribogaine or something like that? Or is it more of a...
Noribogaine, the primary metabolite of ibogaine that goes after 2D6 is a normal part of the ibogaine process, has a similar cardiac risk profile. So it's drugs that are, I think they call them like tabernathologs or something, but ibogalogs or something, I think is what was coined at Davis. But essentially these are drugs where they like try to engineer off that interaction, which may or may not have an effect on its brain effects. And so I want to answer the question I'm trying to ask. And the question I'm trying to ask is, does ibogaine help with certain, human illness? By modifying the molecule, it's not ibogaine anymore, it's something else. And then you're asking the question, does something else help? The view is maybe it's close enough to ibogaine to do something similar. And I've taken like a different stance on this, where I've basically taken the frame of, how do you preserve the molecule and really lean in on the cardiac risk?
How do you put an airbag in the car instead of redesigning the whole car?
Yeah, instead of making it an airborne shuttle or something, I don't know, whatever. So it's putting an airbag in with a high likelihood of saving the person. And so we talk about this in the article, but essentially all the patients that were treated received Torsades like IV magnesium at the start, right?
What type of magnesium?
So it's like magnesium sulfate. So it's basically just like IV bag magnesium. And so what's really interesting about this arrhythmia torsades that everybody's worried about is that the treatment for it, per the American Heart Association guidelines, is to give IV magnesium, which is incredibly safe. And I've given many times for various things in the ER, and you can just give it to people and you'll eventually urinate it out or whatever. And so you can get people through this risk period. They may be slightly hypermagnesiemic or a little high on their magnesium in their blood, and they'll go out and everything's all good. And, there have been about 1,000 operators that have gone down to Mexico so far. And to my knowledge, and we looked into this pretty significantly, there hasn't been a single case of torsades. Conversely, like the New Zealand study that was published a couple of years ago, they had a death out of 10 people. And so we're not doing head to head. I can't tell you for sure what the deal is there, but my suspicion is that if you give what is the treatment for the problem you're worried about before you give the thing that can cause that problem, then it's much more likely that you can knock out the risk or significantly reduce the risk. It's also about doing it in a monitored bed setting. So Tikosyn, Tikosyn, is a drug that is approved for atrial fibrillation, and it's an antiarrhythmic that can be proarrhythmic in the same way as ibogaine, and actually has more risk than ibogaine. The rates of torsades are higher with Tikosyn. It's approved, and it's totally safe. You just do it in a monitored cardiac bed. And so I think that my suspicion is if we're going to do a study in the US with ibogaine, we're just going to need to do it in a monitored cardiac bed with cardiologists involved. And I think if you do that, you're good, right? I think the trick is between now and when, in theory, one could see an approval eventually from the FDA for this, you're going to have to think about, well, not just can this place in Mexico, wherever it is, provide, a good pure form of ibogaine, but what's kind of the wraparound risk reduction there? And I think that's what people have to think about as they kind of think about, that taking on that level of risk. It's not trivial risk, though. It's a real risk. I think the reason why the veterans that we studied were so interested in going is because, as you point out, there's a lot of risks from not doing things, too.
There's also a lot of social proof in that community now.
Oh, yeah.
Right? And like a friend will go down with their friend to like sit in the same room. And it's a tight group, right?
It's a super tight group. And it's pretty cool, right? And I think it's the reason why I did the trial ultimately, my view was there's no way that all of these very high performing special operators are all going down to Mexico and taking this thing, which is not recreational at all, and spending a week down there dealing with this, and then they're not really getting benefit. They're getting some pure placebo effect. It just seemed unlikely to me, given how treatment resistant and how many things that these folks had done, how much time they'd spent in the VA hospital and all that good stuff. And so, that's why we did it. And what we found was enough of a consistent finding and this reversal of disability such that I can't tell you this works because I don't have like that level of evidence on it, that the signal that this could work is really high. It's the highest of any kind of brain acting drug I've been involved in looking at.
Okay, let's talk about the alcohol and the caffeine.
Yeah.
So mechanism of action, I mean, you sort of mentioned the GDNF in the animal models, like the direct kind of injection. How do you think about this, and does it in any way tie into what we're seeing with some of these drugs that are, I guess, designed for type 2 diabetics, like semaglutide and Ozempic-like drugs, but they're having such an effect on various types of cravings that large box retailers are having to revise, sort of in a panic, their sales projections and inventory planning around like snack foods and stuff. I mean, it's wild to see the societal ripple effects.
Walmart apparently has
sure.
Yeah,
and I have friends
sold less food.
Yeah, and I have friends who have been obese effectively their entire lives, never had an exercise habit, and now they're doing pull-ups for the first time, which is, again, not an endorsement because I don't understand, and maybe nobody really quite understands exactly how these things work, but I certainly don't, so I'm not yet there. But how do you think about this? Are there any overlaps with these? Are they completely different mechanisms just presenting similarly?
There's no evidence that there's a direct overlap in mechanism, just because the kind of CNS kind of psych addiction side of things, people are still in the like, is this doing something? Yeah, it looks like it's doing something there, but not any deeper than that. I think we'll learn about that on the kind of Ozempic drug side of things. And then Ibogaine been relatively underexplored from a basic science standpoint. But my suspicion is that it is probably similar enough, and maybe some of the same mechanisms are being enacted, because what you're finding is a similar phenomenon across both instances. We thought these were diabetes drugs, and then there was a significant weight loss observed. And then we thought these were weight loss drugs, and then everybody's quitting all their other habits. And placebo works by a phenomenon called expectancy. And as you can expect from the term, it's expecting something, right? So you're primed to think that this thing's going to help for this reason. I'm always really clued in when you have really obscure, off-target, non-expectancy phenomenon happening. So in our Ibogaine trial, as you mentioned a minute ago, basically everybody quit drinking coffee for a period of time, and like none of them really went into it, as most of us don't. Our coffee habit is maybe a concern. It looks like coffee is like protective against like Parkinson's and some other things, so it's kind of a mixed bag about that, but it's generally the thing we're the least worried about trying to deal with, right? Is a generality. People are much more focused on dealing with being overweight, or focused on, their alcohol use problem, or their, in this case, PTSD and depression and TBI and all these other things that folks were worried about. And so when we started seeing like consistent reports of people stopping their caffeine intake, it was really a signal for me. I was like, you know what? That's really interesting. I mean, there's probably a bigger systemic change that's happening. And what people will tell you phenomenologically about this is it puts a pause in between stimulus and response. At a phenomenal, and I can't like prove this is just what everybody seems to come back and say, it puts a period of time between when you normally have a trigger to do something and go do it, and it was a habitual action, and really kind of gets into this question of free will and all this stuff that people think about, where there's a moment where instead of making the habitual action, the person finds himself in a purely unbiased choice phenomenon. And what people that have opiate use disorder would say in those scenarios when they would relapse after Ibogaine is they'd say, you know what, I had something about it, I didn't crave it, I just wanted to do it or something, wanted to remember or whatever, but it wasn't this habitual action, right? And they go back and they do Ibogaine again after they'd gone back into the addiction, and then they had all the negative consequences, and they'd say, you know what? And they got back to that choice again, and they're like, it's not worth it anymore. I'm going to go this way but they were able to pause and make those decisions. And it sounds like from talking to the various veterans that have gone through our study is that they'd approach things like coffee and they'd be like, I do this, but do I need to do it? Which is really striking, actually. It's not something that people typically tend to do, right? You get into all these habitual actions and your life is just made up of a lot of habitual actions. And they were able to reevaluate all those habitual actions and then establish new patterns. The drug eventually is going to wear off, as all drugs eventually do. And you probably do lay down a level of habituating again. But if you could, during the period of time when your brain seems to be pretty plastic, shift and lay down new patterns that when the drug wears off, assumably you kind of lock into that new set of patterns. And I think that's what's really interesting and probably a little bit different than the Ozempics in the sense that the Ozempics seem to kind of take away from what folks will say a lot of the seeking or rewarding aspects of things like food or whatever. It's just
like cravings.
Yeah, cravings. Whereas this seems to introduce a level of choice. What would be very interesting, so kind of alluded to this earlier, is you take somebody who has a pretty significant addiction like this, and you give them an Ibogaine sort of drug, and then you think about how do you use something like an Ozempic to kind of follow on with that, right? Where you're able to kind of gate some of it. And it's way out there and probably not anything anybody's going to do anytime soon. But it's an interesting idea, right? Of these are essentially habit affecting drugs that we haven't had tools to really use before, which I think is pretty cool.
Yeah. And folks who want to dive deeper into this sort of reopening of, let's call it critical windows. I mean, I'm borrowing that terminology from Professor Nolan, but pretty fun stuff to dig into as well if you want to sort of scientifically, at least for the time being, reinforce what a lot of experienced facilitators have been saying for a long time, which is like the post-period matters a lot. If you're going to have knee surgery, make sure you do your your rehab. All right, let's hop to a few other questions. One is coming back to Ibogaine specifically. The two things that have been of greatest interest to me with respect to Ibogaine are TBI, right? So if someone has no addiction, no PTSD, the only issue they have is some form of TBI. Do you think there is a role for Ibogaine? So we can placehold that. There's part two to this question, which is, I have heard reports, and I haven't gone into the literature on this side. I don't know. Maybe this has been explained somewhere, but I've certainly heard reports of opiate addicts who have seemed to indicate that Ibogaine or Iboga opens a window after treatment during which they do not seem to experience much in terms of withdrawal symptoms. And I want to know what the hell is going on there, if that seems to be observed, right? So those are the two questions. Somebody who just has TBI, do you think there might be a role for an Ibogaine or something like it compared to other options? And then the seeming diminishing or disappearance of, for a period of time, physical withdrawal symptoms.
It's a little tough with the cohort that we studied because they were, it was military TBI. While I understand that the PTSD diagnosis is pretty ubiquitous in the system, it's probably true in a fair amount of folks, especially folks who've been exposed to a lot of combat-related trauma and earlier life trauma. And in our group, it seemed to be there in most of the participants. It was depression and anxiety. And so we haven't studied a pure TBI group. And so the confound is, without studying a pure TBI group that somehow had, maybe it was a competitor in martial arts,
right.
Or something like that.
Multiple concussions or whatever.
Yeah, something like that, where they intended to potentially get hit in the head.
Probably intended to hit other people in the head.
Well, for sure. But intended to go into the ring knowing that you were probably going to get hit. Because the problem, right, is in a lot of these cases, motor vehicle accidents, there's really high rates of PTSD in those because there's not an expectation you're about to get hit in the head. But there's probably a population you could study that's pure traumatic brain injury where...
I'd have like football players, right? I mean,
yeah, it could be football,
a lot
exactly.
of reported depression. Who knows? There could be a lot of other factors involved, but...
Yeah, football players is another great example.
Highly correlated, yeah.
Yeah, and those guys, they're going to hit their head in the game probably at some point. And so that population where it's more of a pure TBI population, you could ask that same question that we asked in this more, mixed population, which is, does TBI disability improve? We saw a dramatic improvement in TBI disability at the 1 month mark, less actually right after. It really took a while for it to work.
If you had to guess, right, we're 2 drinks in and I'm like, Nolan, just give me your wild ass guess. Like mechanistically, what's going on here?
It's this symphony, right? Which sounds kind of like maybe even hokey or like a little like less direct. But I just think that there's something about interacting somehow with multiple different neurotransmitter systems at the same time that must produce this. I mean, maybe the GDNF, BDNF alone could do this. I'm not saying it can't, but I suspect that it's a more complex process. And the problem is we don't have great tools to evaluate that. But sometimes nature trumps our human scientific abilities. And I think that ibogaine certainly is there in 2023. It's like the story of scurvy, right? Like we associated eventually, after like a bunch of weird stuff, we eventually associated eating oranges with improvement in scurvy, but it took us another 100 years to synthesize vitamin C.
Yeah.
And so that's, I think, what's so hard about this scientifically, and to get the kind of scientific community fully on board with these ideas, is that we're likely going to figure out this works before we have any idea on how it works. Your second question, which is, I'm going to answer it the same way, but it's very unique to ibogaine. You can take somebody who's going through florid opioid withdrawals, and you can have them not only have a cessation or stopping of a desire to go take more heroin or prescription opiates or whatever it is, but you can have them basically blunt or completely attenuate the physical withdrawal symptoms of withdrawing from opiates, which is diarrhea, like headache, sweating, all the stuff that people will go through when they're going into opiate withdrawals. And this seems to really kind of like knock that out. It's likely, again, that because it's interacting with the opioid receptors, it's interacting with the glutamate system, but it is, to my knowledge, none of the other psychedelics can do that. Ketamine can't really do that. So this is a pretty unique thing to ibogaine that it can pull this off. And why I think it's such an important drug to understand. I mean, I would argue that because of how broad ibogaine seems to work across now most of the major psychiatric diagnoses, with the absence of something like schizophrenia, but anxiety, depression, PTSD, this traumatic brain injury, multiple different addiction types, it's going to behoove the scientific community to really kind of break down why it does what it does over the next couple of decades, I think, and try to really kind of back engineer what it is. But yeah, we have no idea.
Outside of the lab and more in the wild, what are some of the more interesting things happening related to ibogaine and iboga? I believe there's something happening in Kentucky.
Yes, I've been down to Kentucky to testify in front of the Opiate Abatement Commission of Kentucky. It was myself, along with Srini Rao, Matai, Deborah Mash, who's CEO of Dimerex, was at the University of Miami for a while, and Ken Alper, who was at NYU and is kind of an academic private practice psychiatrist. And there's a guy by the name of Brian Hubbard, he's a very interesting guy. He's an attorney by training who has worked in a bunch of different domains within Kentucky state government and whatnot. And he, for one reason or another, has become completely convinced that the money that ended up being some of the lawsuit money for some of the opiate overprescription that happened, particularly in Kentucky and West Virginia, but all over the country, should be utilized for novel therapeutics and not just for more of the same sort of treatments that we have available. The conventional treatments that are available for opiate use disorder fall into the realm of what we think about as replacement therapy. You're replacing a higher risk opiate with a lower risk opiate, so that's Suboxone, which contains buprenorphine and methadone, or opiate blocking drugs like naltrexone. There's a fairly high fail rate on those drugs. Part of it is psychosocial. We put people in the right environment. You could probably drive up the rates of that. There's also a prescription issue. You used to have like a special FDA license to prescribe it. I used to have this thing, and then recently that was knocked out. So everybody with a medical license can prescribe Suboxone. And so there's kind of a group of drugs that can do some work on this. But there's certainly folks that we would think about as treatment-resistant opiate use disorder patients. And the numbers I'm not going to get into because they're debated or whatever. But whatever those numbers are, it's a good chunk of folks, and they don't really have much to offer. And so people have thought about lots of different options for them. And one of the options is brain surgery. So in West Virginia, a group of neurosurgeons are actually doing full-on, there's a surgical form of neuromodulation called deep brain stimulation, where you can actually put an implanted device into the reward system. And also, kind of similar to to some of these Wegovy kind of drugs, you can drive down some of the pleasure around, and this is more theoretical at this point, but opiates, as well as there's some data out of, a couple of different studies with even like weight loss for stimulating in the reward circuitry. What's interesting is that there's a 1 in 100 risk of a head bleed from that treatment. And about a third of them, it ends up being a pretty significant head bleed, right?
Yeah.
And so what's really interesting is you have no one in West Virginia organizing all of these hearings about it. It's just happening. They're letting people do the science and all that stuff. And I don't disagree with doing that, by the way. I think it's a useful thing to explore, and it may be a solution for this. And this is, as we described earlier, such a high risk phenomenon that a 1 in 300 risk is not
is
bad.
it 1 in 300 or 1 in 100?
1 in 100 risk for the DBS. It can be a trivial, just blood on the tip of the electrode, which is asymptomatic. About a third of those people are going to be, in a more
have a complication.
Yeah, have a real complication. So, and then you've got about a 1 in 300 risk of a Torsades risk with Ibogaine, right? And so next door in Kentucky,
similar odds. Yeah.
Yeah, you got a similar odd concern, both of which can be kind of dealt with in the hospital. I'd argue that the Ibogaine risk is probably a little less actually than the DBS risk if you just kind of look at everything. And they're having these significant hearings, and there's a lot of opinions about this, and a lot of
shocker,
right? And I'm one of the few people that does all this stuff, so I can kind of, and you juxtapose.
Well, that's part of the reason we're having this conversation, because you bridge a bunch of interesting, often separate worlds. So anyway,
yeah, thanks, man. Yeah. So I went down there, and there were a million questions about the cardiac risk and about whether or not this should be done, and particularly should state funds be funding this, and there are various opinions about that. My opinion, and the reason why I was willing to go down there and support the effort, is there are a subpopulation of people in which Suboxone, naltrexone, and methadone don't work. And we need to spend some money on trying to help those people.
Also, working is, quote unquote, working has different outcomes, right? If you're talking about like substitution therapies as well, right?
Yeah, no, I think you're totally right. I think it is living on opiates, if you're having to do this your whole life. I mean, it's tricky. You lose your prescription in a flight to wherever, and then now you're in a really bad place. And so this idea of, instead of replacement or substitution or whatever, interruption, which is what Ibogaine is going to do, and I think at some level what DBS is going to do too, right? It's going to interrupt that system, that circuit that's driving the seeking behavior, and be able to kind of reorganize the brain such the person approaches the problem in a different way, is a promise that I think everybody wants to see. I think the interesting part about this whole phenomenon down there is, from the folks that are opposed to this, is this view that, one, that the current treatments are fine or whatever, and then two, that how could it be that this extract from a root in an African country somehow be something that can do what modern humans in pharma can't do? And it goes back to what I think is a pretty hubristic part of the human psyche, which is that I need to start the fire. I need to hammer the wheel. I need to, and I think at some level,
the sort of not invented here kind of thing.
Yeah. Yeah. Right. And I think the idea that somehow this just exists, it goes around the psyche in a way that doesn't really work. And we saw this with scurvy too, right? I've spent a lot of time studying scurvy because I'm very interested in this human phenomenon. There were people called anti-fruiters. I'm not kidding you. It's a real term.
Wow.
And they were in the Royal Societies in the 1750s. And so we knew from 1498 that folks that were going around the Horn of Africa and going to Asia that way, they'd plant citrus trees all the way there. So we were doing this. And at some point, scurvy got worse and all that. And people said there's literally no way that these fruits could be the solution for this. Humans have to solve this. And actually, the fruits are probably what's making it worse. Yeah, so James Lind ran the first clinical trial in the history of humans on scurvy and citrus fruit, where he gave all these various weird concoctions like poisons, and they were trying to give people cyanide, they were trying to give people alcohol mixed with acid. This is what they thought. Yeah. And so he randomized people on a ship with scurvy to these various things in citrus fruit. And what happened was the citrus fruit receiving people at the end of the week were taking care of everybody else. But it took another 100 years. I think this is this meta phenomenon of people need to feel like they made it in that culture, within that context, that this is the latest and greatest thing. It needs to be kind of like very proximal in time. It needs to be new, it's got to be the new thing to be the solution. And I think that's part of what's going on in Kentucky from my view of it. Because if you look at West Virginia and you just look at like the actual information of what's going on, you'd probably be more likely to cause, and I don't think that people should, but question the brain surgery thing, if you really get down to it, over the Ibogaine thing, just on the risk portfolio and having to have an implanted device for the rest of your life. But nobody's saying, there's like nothing there. And it's because we're making this. Western society is making this really innovative new treatment that requires a brain surgery and da-da-da-da. And that's totally cool from their perspective. And I think that we've got to, as a culture and as a scientific community, really change the way that we think about evaluating tests and particularly therapies and look at the inherent scientific complexity and not the temporal proximity and the fact that we made it or whatever, those sorts of things that I think drive people to have these misconceptions. And so Kentucky's really interesting. It's really an argument about whether or not some of this money should be earmarked and whether or not it should be studied. And I think both of those things are a yes, we should be. It's the best candidate that we know about. And the risks are mitigatable and similar to DBS.
So many facets to this, like insurance reimbursement, scaling, therapist availability, or I should say more medical availability for like the duration of stay that would be required with Ibogaine versus like there's so many facets to all of this in terms of, say, getting to patient 10,000, right? For whether it's this DBS, implant surgery, or Ibogaine, right? There's so many levels of nuance. But at the basic science level and the further research, who am I to say, but it seems like the cost and severity and prevalence of the problem is such that the answer is, of course, yes.
Yeah,
right?
yeah.
Of course it's yes. I do want to ask you about synthesis, specifically related to Ibogaine, because I'm always fascinated by rate-limiting steps and also unintended consequences of using different compounds that occur in nature. Before we get there, I want to very selfishly throw in a wildcard question around IRBs and funding studies and getting ethical approvals, because I would love to see more studies on extended fasts in humans. But to my knowledge, those basically got taken off of the table. If I wanted to try to make the case and fund some science related to extended fasts in humans, any suggestions?
I think everything's studyable if the risk-benefit ratio is on the right side of things. At least at Stanford, I think that's the evaluation, is extended fasts in normal healthy controls. But I think if you can make an argument for some sort of medical, psychiatric, whatever it is, condition that you think that the benefit of doing that significantly outweighs the risk,
I think I can make that case.
Then I think you can do it. Yeah. And so it's really is just that, right? It's this ethical, and I think I agree with it, right? It's this ethical justification that we're going to be able to do more good by trying to do something like this than to do harm. I mean, a study that would never go through any IRB is, we're going to randomize people to no motorcycle helmet or motorcycle helmet and have them do laps around the university. We pretty much know the answer to that question, and the benefit of knowing in a randomized controlled trial way, the benefit of the answer to that question, does not outweigh the risk at the individual patient or participant level of participating in a trial like that. So that trial would never get done, right? And so I think that's the way that we have to kind of look at it. So if you've got a reason, your reason is you think that there's going to be some effect on coronary artery disease or something like that.
I think there are a couple of different approaches I could take, just in case there's anyone listening who wants to do this. And there are people study fasting in animals all the time, but it's for whatever set of reasons, at some point it seems to have been taken off the table for human subjects. I mean, there was research done, I want to say, up until maybe the 40s and 50s, but then it kind of vanished. And I'm very interested in, if I had to make the case, I would probably make some type of case around what Chris Palmer at Harvard and other people have called metabolic psychiatry. So to look at this almost like the accelerated TMS equivalent of a ketogenic diet for certain psychiatric conditions, because you see some incredible results. And Chris has been on the podcast with, say, ketogenic diet as applied to conditions like schizophrenia, for instance. Remarkable transformations where people get off of half a dozen or dozen medications. And like you, I am interested in practical solutions, and especially things that are uncrowded from the perspective of scientific support, which for a while has been psychedelics, but certainly accelerated TMS. I'm agnostic when it comes to the tools, and I think I'd probably make the metabolic psychiatry argument. But the fact of the matter is, I also feel like it's been so long since we applied modern tools and tracking of biomarkers and so on, everything that we have at hand now to human fasting. That may not be the argument that I would use, but certainly there is that. Okay. So synthesis. There's a great piece that came out in National Geographic not too long ago by a journalist named Rachel Newer. I think I'm getting the last name right. N-U-W-E-R. She also has a great book on MDMA and MDMA-assisted psychotherapy, the history and implications that recently came out. And she traveled to, I think it was Gabon, although I think there is also, I think you can also find iboga in Cameroon, if I'm not mistaken. And she went on the ground to look at all the implications of global demand for ibogaine and iboga. And it's very, very nuanced, but it seems clear. And I wrote a piece a long time ago on my blog, which was a letter to users of psychedelics, like a plea for a more ethical menu of options, something like that, to just point out some of the diminishing natural supplies for, say, peyote. Almost certainly going to go extinct. Yep. Use something else. Use San Pedro cactus. Look at the growth cycles. Just don't touch it unless you're part of a culture that has this as an integral part of tradition and healing, as would be the case for, say, people who are in the Native American church and so on. But ibogaine can be had in, I guess, a number of different ways. Maybe you could speak to like the known options and then looking forward what some of the most interesting options are for whether it's like extraction or synthesis.
There's kind of the straight extract out of the iboga tree, as you're pointing out, and that one's probably a pretty big ethical issue, because what's happening, and I think that National Geographic article really reflected this, is that there's such a global demand that it drives the prices up in the Bwiti, the peoples that take iboga in Gabon and in surrounding countries no longer can access it because of the high cost, which is the last thing that you want to have happen, right? That's the thing that everybody, I think, should be trying to avoid first. And so what else can you do? So another way to do this is that there's another tree in Ghana and other places in Africa that has voacangine. This is Voacanga africanus tree, and has voacangine, which is a very similar but not identical alkaloid to ibogaine. It's actually not even a controlled substance, so voacangine is not on the controlled substances list. And it's not as much of an issue because there's not really a current medicinal usage of voacangine or utilization of that within those cultures that have these trees.
It's also more commercially cultivated, if I'm not mistaken, right? For maybe fragrances or something. I can't recall the commercial use.
Yeah, and it's pretty ubiquitous too. I mean, I've heard that it's not just in Africa; that it's in some of Central and South America. And so you can extract the voacangine, and then you can do this simple chemical step to get it to ibogaine. To do a synthesis pathway of ibogaine from de novo, it's like 26 plus steps or something like that. But this is like the last step before it's ibogaine from voacangine. And so it's really pretty straightforward to do that. But you're still talking about a botanical. You're still talking about essentially growing a plant to derive a chemical out of the plant. So the other way to think about it is, could you do a full chemical synthesis? And people have looked at that and tried to do it. It's very hard though, because ibogaine has 2 chiral centers, so it has the potential for 4 stereoenantiomers, and that chemistry is complicated. And so full synthesis is a tricky process. My suspicion is that whether it be biosynthesis or straight full synthesis, but there's got to be a way to make this that avoids trees eventually. I think it's better for the environment. It's going to be more scalable. It's going to be something that standard pharma is going to want to see happen to really be able to use it. But there's still some time to get from A to B as far as that goes. So I think it's not a done deal. It's not completely figured out yet.
So bridging from that, I mean, this is actually a completely separate question, but also raises some sustainability, ethical questions. 5-MeO DMT, so 5-methoxy DMT. So first of all, I would really implore people, I'll link to this in the show notes as well, read the blog post that I put together. So the 5-MeO DMT, it's present in quite a few different plants, different nuts. Most people who have heard it in the zeitgeist know it within the context of Bufo alvarius. There are other scientific names for this toad, this Sonoran desert toad. And that has turned into a huge mess in terms of like cartel harvesting and over-harvesting from these poor toads. It can be synthesized. There are ways to synthesize it. Hamilton Morris has beat the drum about this to his credit. People are not going to like this, but there is no documented indigenous use of the Sonoran desert toad. Ken Nelson, you can look it up, in the 80s, produced a pamphlet after testing God knows how many things. Brilliant amateur biochemist, but nonetheless, it is very, very, it is interesting and appealing on a whole number of levels. A lot of people are trying to commercialize it because, at least in Earth time, it is a short experience, right? So, well, it's going 10 to 20 minutes, 10 to 15 minutes. So from a business model perspective, I understand the appeal, much like I understand the appeal of the newly branded psychoplastogens, right?
Yeah.
Psychedelics with the content/mind-altering aspects as removed as possible. We might come back to that. But my question related to this is not so much on the production side, because people can read about that separately, and I think it's important for people to read about. It's more of practical use following ibogaine administration. I believe I've heard people describe its use on what some people call the gray day following administration. Could you speak to this? Because I'm trying to discern for myself how important or critical it is from a therapeutic outcomes perspective versus being a business differentiator. Does that make sense? Like, this is something we kind of, we put a nice set of icing on top of the cake, and that includes this, what can often be a sublime experience, not always for people. It can be destabilizing for some folks in the form of 5-MeO-DMT. So what's your take on this?
So we specifically made sure that folks weren't getting a second kind of confounding drug on top of the ibogaine to figure out what the ibogaine effects were in isolation. And as I described earlier, we had extremely remarkable effects in the absence of doing the 5-MeO. I think what people say about this, the 5-MeO, is that it just takes the edge. At minimum, it just seems to take the edge off the gray day, which is a day that happens for not everybody that takes ibogaine, but a fair percentage of people, such that there's a name for it, where people, for some reason, end up having kind of a bad day in and around day 2, 3, where they really have a hard time, and then it goes away the next day.
Hard time meaning depressive symptoms.
For some people.
What is hard? Okay, yeah. What makes it hard? Anxiety.
Yeah, anhedonia, low motivation, sadness. I think probably what's going on is there was like a serious kind of flooding of your CNS with a whole host of effects from this drug, and the brain's then kind of reacting to that, and then it seems to kind of rebound out on its own without the 5-MeO. But it sounds like, from what I've heard, the 5-MeO kind of bridges people out of that, so they don't have to really have to experience that feeling. Now, the question would be, does it do something else beyond that that's useful? We have no idea. I suppose what we could have done, or maybe what we could do in a subsequent study, is to just randomize people to getting no 5-MeO after or 5-MeO, and we could actually answer that question. Does it have an effect in the long term? It's hard because there's like a floor effect of just like the profound improvements that we saw just from ibogaine. So my guess is that the statistics would tell you that you have to do a pretty large sample to be able to see something if it's there with 5-MeO, just because everybody's flooring out just with ibogaine.
When you say flooring out, does that mean that the amplitude of the effect is so great that you would need to, in terms of like seeing a large percentage improvement over the ibogaine, you'd need to see something great? Or what do you mean by flooring out?
Yeah. So essentially we're seeing people drop down within that normal range.
Flooring out on the assessments.
On the assessments. You'd need to see, and people are going into the range of like a score of 5, 6, something like that on various scales, the PTSD scales, the depression scales, which are in the normal range. And so you'd have to zero people out with a 5-MeO essentially. Or the other thing that it may do, which nobody knows probably, is whether or not it makes some of these folks that and you'll see in the paper, there are a couple of people that relapsed at the month mark. Maybe it helps the durability on some people. It could do those things. So I'm not saying that it doesn't have a benefit. It's just, it would be a hard study to deal with. And I think from like a purist, I want to see this go through the FDA and kind of do the FDA things and see if we can get, the first drug kind of through the process. I don't want to say it's a distraction from a U.S. kind of scientific regulatory strategy standpoint, but it's definitely something that would add complexity. So I think at the level of clinics that are doing this in Mexico and they have free range to use these substances, I don't think it's on the face of it like a terrible thing to do. I think it makes sense why they're doing it.
Do you really think that? I guess just to push on that a little bit, I'm like, okay, so people have a hard day, but it's known that this is a phenomenon, so they could prep people for the possibility that they would experience this hard day. If they're not somehow edging into dangerous territory where they're likely to self-harming. I mean, 5-MeO-DMT, I have some experience with it. I understand the appeal. It's like Satchitananda, et cetera. But it's not risk-free.
Well, you're strapping yourself to a rocket.
Yeah, I mean, that is a big, big gun, right?
Yeah.
Which is not to malign anyone who is using this in a clinical setting, but it's not risk-free. I mean, I have friends who are very experienced psychonauts. We're talking like 100+ reps with things like ayahuasca who have been pretty much even keel with their various experiments and been knocked pretty sideways for non-trivial periods of time by 5-MeO-DMT. Maybe that's just the sample set that I'm dealing with, but...
Yeah, and I totally agree with you. You know, medicine is a discipline and a profession of risk mitigation and risk-benefit ratios and everything. And anybody that would proclaim themselves to be a physician scientist that doesn't believe that isn't seeing it as it is. Everything that I do is some sort of risk mitigation exercise where I'm looking at this thing has these risks, but this person has these inherent risks, and how do you square all that? I think, to your point, it would totally make sense if the person was in such a bad place in the grade A that you were worried about them. I think there's a justification there. If you really, as it seems that they do, have some general experience that this was helpful to kind of getting folks out. The reality is that we're really not going to know much of anything, and a lot of this is going to be in the realm of anecdote until we do the trials in the U.S. and really thoroughly document everything that happens with this drug, with Ibogaine, with 5-MeO, which, as you know, people are trying to put through trials and commercialize that. And so I think there's a moment where we'll be able to kind of rectify all of this and figure it out. I agree with you, too, that I think that where MDMA may be a substance that certainly not everybody could use, but like a decently broad population-based drug that a fair amount of the population that had PTSD could go after. I think that these substances are more constrained to a smaller population where the risk benefit is right for them. And so absolutely, it's a tricky moment. I think we know just enough to be dangerous in some places, and we got to get through this just enough to be dangerous moment to the like we know how to not be dangerous moment as a culture, and do that with kind of the scientific process.
So much earlier, you were laying out psychiatry 1.0, 2.0, 3.0. I'd love for you to feel free to speculate, right? It's going to be speculation, but putting aside like I know it's hard to do, but like shepherding stuff in its simplest form, cleanest form through the FDA, et cetera. But like, what might psychiatry 4.0 look like?
That's
right. In the sense that, for instance, something that's on my mind, and I'll keep it short, is, as I understand it at a very primitive level, the way that some of the accelerated TMS protocols work from a hardware perspective is you're kind of hitting nodes at the exterior of the hub and kind of triangulating in a way to hit what you're trying to hit. But perhaps you could use, for instance, in my conversation with Nora Volkov of NIDA, she's talking about focused ultrasound.
Yep.
So maybe you use that to hit the deeper structures directly. You hit the nucleus accumbens or whatever it might be. And then related to that, if we're talking about like Freud and so on, focusing on content, and then you've got this sort of neurotransmitter focus. So it's this serotonin issue. And then now you have the electroceutical kind of structural nuance and experimentation. But it seems like these things aren't necessarily wrong. They're just, at least if we're looking at the content of the molecules, incomplete. But if you talk to a lot of these guys who go through, say, and gals, but a lot of these operators are men who go through the Ibogaine experience, I mean, they will, and maybe there's a visibility bias because they can't see what the hell's going on in their head, but from a chemical perspective, but they can remember the content. But like a lot of people would attribute the therapeutic effects to much of the content, right? This reconciliation and so on. So what might psychiatry 4.0 look like?
We have a paper coming out soon where we're actually trying to use neurostimulation to change trait hypnotizability to make people more suggestible transiently.
Mm-hmm.
And it's probably an ability to zero in on specific content and manipulate that content through circuit-based intervention, And that's like a pure speculation, but I'll give you an anecdotal kind of case report example. And so there was a patient who got a similar sort of deep brain stimulation approach that I was describing earlier that they're looking at in West Virginia for addiction. And that individual received deep brain stimulation, I think in Europe, I think for OCD. And he had a normal musical taste. He listened to whatever, all the range of standard artists. And then he got his deep brain stimulation and he became obsessed with Johnny Cash. Like totally sold all of his...
Didn't see that coming. All right.
Yeah. So totally sold all of his other albums and listened to Johnny Cash. And the batteries for these deep brain stimulators will wear out after time and you need a new one. And it's decently common that if the person's doing pretty well, then they will forget to come in and then all of a sudden their battery's dead and then they'll have a reemergence of symptoms. And so this gentleman did. So I think it was his OCD, and his OCD got worse again. And he fell out of favor with Johnny Cash and threw away all of his Johnny Cash albums and started listening to whatever he was listening to before. Went in, got a battery change. The battery was put back in. And
he's like, for fuck's sake, I got to go back to the shop and buy my Johnny Cash.
And that's what he did. Yeah. And so just like we don't really understand how Ibogaine works, we really don't understand what happened there, right? It was a very illustrative case. And I love talking about that case because it gets into this area that I think people are really worried about right now about specific content manipulation. I don't think we can do that. We don't have the tools to do that. We have these like broad tools that basically change the lens of the world that you look through. Like I can change your brain in such a way that you're like, for some people, they're going to see rose-colored glasses where they saw blue before or whatever.
Right. It's like I can give you a different set of glasses to watch the movie, but I can't change the movie directly.
Yeah, they can't change the movie directly. My suspicion is that we're going to edge into a world where maybe we can change the movie. And that's where it starts to get both very interesting and very ethically complicated. And that story about Johnny Cash, that doctor had no intention of doing that because nobody knows how to do that. And maybe they played Johnny Cash in the OR, maybe not. They didn't report that in the case report, but there's no clear sense of why that happened either. Is this the first song that was playing in the hospital when he woke up and his brain, the reward system just kind of like attached to it or whatever? But it's one of these things where we're going to get to a place of sophistication. And I think we're going to be able to do that. And what happens in medicine, as I see it, is we're always redefining what's illness. It used to be that high blood pressure was like 150 over 100 or something, and then it was 140 over 90, and then it's 130 over 80, and now it's 125 over like 75 or whatever it is. It's not that the illness has changed, it's our definition of illness changed. And so, my suspicion is that as we have enough tools to be able to knock out these major mental illnesses, which are effectively like end states, right at the end of the day, we let the system go all the way to like this kind of completely semi-functional end state where people have semi-volition and they're kind of stuck in these mindsets and these behaviors. If we can figure out what that is and we have ways of intervening sooner in that process and we have emerging tools that can help you with this sort of content targeting manipulation sort of thing, then I think you're going to be talking about much more specific sort of interventions. That's like very sci-fi though. It's not something that I think there's even a hint of. I wouldn't even know how to tell you how to do that now. Our like one shot on goal is just to move around this brain trait. We do have a study with Rog Aaron where we're actually packaging ketamine into nanoparticles, infusing them through an IV into the bloodstream, and then using ultrasound to kind of open the nanoparticle ketamine and drop ketamine just in the cingulate in the area that we were talking about earlier. In this case, in pain patients, because it's easy to measure pain scales and pain reactivity. But what I think will be really interesting with that is if you could take that same technology and start to drop various psychedelics into specific brain regions, and you can do a behavior mapping exercise. What's necessary and sufficient to produce the clinical improvement? What's necessary and sufficient to produce the trip? And I think that's going to be way more important than modifying the molecules. Because it's like a confound. We're not really answering the question of does tripless Ibogaine work? Because it's not Ibogaine, it's just some other thing, right? But what we really want to know is, does tripless Ibogaine work because we just put it in the amygdala or just into the cingulate or something like that? And that in isolation isn't sufficient to produce the trip, but it's sufficient to produce a therapeutic effect. If we can pull that off, we're going to start next year on that. That's going to be super cool because it's going to give us the ability to have more of these questions. And you could even think about it like if you had a long-acting anesthetic, right, where you had somebody with pretty pronounced psychosis, schizophrenia symptoms coming in, and you were able to shut down their amygdala for a couple of days with an anesthetic just in the amygdala and nowhere else. They're totally awake. They're still with you, but their fear response, or into the singular, their kind of salience of the environment response goes down because you're able to kind of temporarily shut it off. But you're not having to give like a whole body, whole brain anesthetic where you're putting somebody into a medical coma or something. You're just shutting down this one area.
Which you could potentially do through neuromodulation and not pharmaceutical, right?
You can. So people have tried to do that. With deep brain stimulation, you can actually do a jamming signal in certain areas and shut it down too. And that may be the long-term solution, right? You're using drugs, like focal drugs, to test it. It's a commitment. It's not something you can do in an emergency.
Yeah, right.
But you could, in theory, do this in the ER. You could take somebody that was acutely psychotic. You could put an anesthetic that could kind of shut down that system for transiently for a couple of days. And you could kind of get them more on board with thinking about what the long-term solution is when the fear system isn't in place as much. All total speculation. It's not something I have any direct data to support, but it's definitely interesting.
Let's push into a little bit more sci-fi because it's fun. And also a lot of things that start in sci-fi end up in sci, right?
Yeah,
so to speak,
true.
right? I mean, you look at Snow Crash by Neil Stephenson, and there are many examples. But do you think you could change handedness, hand dominance?
That one would be hard. I think it's possible to do that at childhood. And we do this in stroke, right? We do this constraint therapy sort of stuff where you actually constrain if you have a big stroke where you have on one side of the brain, you have a pretty devastating stroke where people can't move their arm and all that good stuff, or they have minimal movement of their arm. And then they have an intact side that's totally fine, right? You actually constrain the intact side and force the person to use the affected side to drink water or to write or whatever. And when what you're trying to do is to kind of reorganize the neural system in such a way to where there's more cross-functional like attribution of that side. And so we have some evidence there's ways to do that. There's kids who need corpus callosotomies and various different like pretty significant like say epilepsy surgeries when they're really, really young, like 1 year old, 2 years old, 3 years old, whatever. And when you look at those cases, they can lose like a pretty substantial part of their brain from whatever surgery they needed to deal with their problem, or if they had a trauma or whatever. And they can reorganize the system to be able to reallocate resources to be able to do bilateral sort of functions. And so it's mostly that the brain gets fixed. You know, the interesting thing about this idea of critical periods, and maybe what Ibogaine is doing and whether or not you can make a more plastic brain, is this idea that if you could bring the brain to a more juvenile state, then you could probably neuro-rehab it better. And that's going to be, I think, one of the questions that will come out of the data that we're going to present is, how far can this go? I mean, we saw like people go from mild to moderate TBI disability to none on average, which is awesome and like never heard of. But if you keep pushing on that, how far could you go with something like that? And that's going to be a question that I don't have an answer for, but at least there's like a signal there to look. That's kind of part of what I like about the general work that I try to do is I like to be relatively disrupting, and I like to be in spaces where nobody else is working. I start to not like it when everybody's doing it.
Yeah.
So I'm like always now, like, where am I going? I'm always looking for the thing, or nobody's really in that space studying it. I always like it when people think if people think it's like really weird, it's like a positive signal that I need to do it kind of thing. And so I think certainly this area of using psychedelic drugs to try to treat neuro deficits is not something that a whole lot of people are really like looking into right now. So it's pretty curious, and hopefully we can ask some of those questions.
One aspect of the accelerated TMS, in terms of case reports, maybe too strong word, anecdotal reports that I found interesting, is it seems like some folks report increased visual acuity or like color contrast. And I found that very interesting for a few reasons. Number one is that it's very commonly reported, say if you're on lower doses or higher doses, but let's just say low to moderate doses of certain psychedelics,
Yep.
right? It's sort of like the dial on your HD visual perception is set forward a few clicks, right? The flowers sparkle just a little bit more. I mean, you notice details you would otherwise not notice. And the reason I'm bringing this up, I mean, that raises a lot of questions, but I'm bringing that up specifically because there are athletes who have talked about the performance enhancing benefits of some types of psychedelic use.
Yep.
And I think Aaron Rodgers would be one example of this, although I don't want to say it's sort of in-session use. It's, I think, more longer-term implications. However, there are people, certainly, I know athletes who have used these things to enhance their perceptual faculties, which then leads me to wonder and almost assume that neuromodulation will be used as a very hard-to-detect means of performance enhancement in sports. It's hard for me to see how that would not be the case. With people who are willing to, I think there was some type of poll done at one point. It's like, would you be willing to take a drug that would guarantee you to get a gold medal, but it would reduce your lifespan by like 5 or 10 years? And the answer for this thing that it could be all made up, who knows?
Yeah.
But I remember the report supposedly indicating that the yes answer was very, very high percentage of respondents, right? So if they're looking at something that has a lower risk profile and is basically going to be impossible for like the World Anti-Doping Association to
Yep.
track,
Yep.
why wouldn't they try it?
Absolutely. I'll tell you, we've had a number of patients who've gone through and they remitted really early. So they lost all their symptoms really early in the week. So like day 1 or 2. And then by day 3, they've like zeroed out. And then like Thursday, like day 4 or 5, they're coming in and they're saying, you know what? I remember this one guy who's like, I was driving by the beach and I saw the sun setting or whatever it was. And I wanted to stop and for whatever reason, just like sit on the beach. And I don't normally do that. And then he described how he was like completely present in the present moment and able to just be there and present and was like watching the water for an hour. And he said, I've never been able to do that before, but I used to do these mindfulness courses that I couldn't understand. And it felt a lot like that. And I went and found my book and it sounded like I was having this kind of like totally present, mindful moment. And I've had a ton of folks come back and tell me this. So if they remit really early and we keep treating them, we treat them through. And it looks now that, we've had folks come through for this and folks come through for psychedelic treatments. It looks like day 3, 4, 5 out of a psilocybin experiment where you've got the person's no longer having any trip, but they're just calm and peaceful and kind of pretty relaxed and present. And it's very similar to that. And so I think that you're probably getting a similar or the same state there. And I would assume a state where a lot of good performance can happen from, right? Because you really are truly in this moment, not thinking about the present or the future. I've had a lot of folks actually offer, and at some point we need to do this, but offer various philanthropic gifts for me to run trials on athlete performance.
I knew it. Of course.
So I had, one of our donors said to me, I will give you the money if you will take me and all of my group of friends.
All my post-finance guy triathlete friends.
It is basically that, yeah. And we cycle every morning and randomize us to sham or active stimulation before we get on the bikes. And he's like, the reason why this is good is because we make the same exact times and everybody knows their times and da-da-da-da. And can you change this? There's a little bit of evidence for this. It was a paper that was published a couple of years ago where they took people and taught them to do like complex motor tasks, like hand tasks, where it's like tap digit 1, 3, 5, 1, 3, 5, 1, 3, 5, and then intersperse it with 2, 4, 1, 3, 5, 2, 4, like that. It's like a complex kind of multi-step finger task. And if you prime the motor learning area before you do that, you can cut the speed of acquisition in half compared to the people that had sham.
That's non-trivial.
Right.
Seems non-trivial.
Yeah. And so it's interesting, right? Like there's some really early, like preliminary data to suggest that you could potentially improve performance with neurostim. The thing about it is that if you could have something that, people have been thinking about TMS as a treatment for insomnia, others for acute anxiety, if you could come up with something that could put the brakes on a couple of different symptomatologies, and you could make, maybe it's a TMS device, maybe it's another technology, you can make it something you could bring home, then you'd have the ability to have this kind of full service sort of process for dealing with things. I think trying to treat depression in isolation or something like that, you're never going to be able to scale one treatment alone. But if we get to a place where we can use this for a lot of different functions and actually, this hypnotizability stuff drive people up to be able to receive information better or study better or whatever, do motor tasks better, and then turn it off and flip it on to like sleep mode, and you had a level of more control over your brain than just your own volition. It's your volition plus your volition to do these things. And I think it's very interesting. It's also very sci-fi, though. I mean, we're not anywhere close to knowing we can do that yet.
Yeah, not anywhere close yet, but fun food for thought at the very least. Nolan, one more time, where can people find your lab online?
So it's bsl.stanford.edu. It's the Stanford Brain Stimulation Lab.
Great. And any other websites you'd like to point people to?
No, I think that's the place to go.
That's home base. Anything else you'd like to say before we wind to a close? Any comments, public complaints?
No, it's been super fun. I mean, I think you've definitely gotten yourself quite up to speed and kind of right in the center of a lot of the pulse of this, both on the neurostim side and the psychedelic
pulse.
side. Yeah. And so appreciate the kind of the knowledge coming in and your interests, and appreciate the ability to have a conversation around these topics. So,
well, thank you for saying that. I really have enjoyed delving into this field. You've been incredibly helpful as a resource and a sanity check, since I get all excited about things and sometimes can fly off the rails. But it's been so much fun to engage with this burgeoning, hopefully soon to be dramatically expanded sort of field of experimentation, especially given the remission rates and the durability. I mean, I've seen, and the reason I first began exploring this was I saw a friend's family completely transformed. And the before and after was just one of the most unbelievable transformations I've ever seen in my life. And it happened quickly. I think it was about day 3. Many, many failed interventions, really critical situation, lots of self-harm. And it was just like Control Z, undo, and back to the person they used to be. And it's been durable with, I want to say, let's call them single day boosters, maybe once a quarter or once every 6 months. And I think it's now been durable, I want to say probably a year and a half, which is just phenomenal. So I appreciate the work you do. I appreciate you being the last man standing on the scientific bachelorette. And I suspect that'll happen again. And thanks for taking the time for the conversation, man. Look forward to watching what you do in the future. And for everybody listening, we will link to everything we discussed in the show notes, including Nolan's lab at tim.blog/podcast. Until next time, be a little bit kinder than is necessary to others and to yourself. And thanks for tuning in. Hey guys, this is Tim again. Just one more thing before you take off, and that is 5 Bullet Friday. Would you enjoy getting a short email from me every Friday that provides a little fun before the weekend? Between 1.5 and 2 million people subscribe to my free newsletter, my super short newsletter called 5 Bullet Friday. Easy to sign up, easy to cancel. It is basically a half page that I send out every Friday to share the coolest things I've found or discovered or have started exploring over that week. It's kind of like my diary of cool things. It often includes articles I'm reading, books I'm reading, albums perhaps, gadgets, gizmos, all sorts of tech tricks and so on that get sent to me by my friends, including a lot of podcast guests. And these strange esoteric things end up in my field, and then I test them, and then I share them with you. So if that sounds fun, again, it's very short, a little tiny bite of goodness before you head off for the weekend, something to think about. If you'd like to try it out, just go to tim.blog/Friday. Type that into your browser, tim.blog/Friday. Drop in your email, and you'll get the very next one. Thanks for listening. This episode is brought to you by 8 Sleep. Temperature is one of the main causes of poor sleep, and heat is my personal nemesis. I've suffered for decades, tossing and turning, throwing blankets off, pulling the back on, putting one leg on top, and repeating all of that ad nauseum. But now I am falling asleep in record time. Why? Because I'm using a device that was recommended to me by friends called the Pod Cover by 8 Sleep. The Pod Cover fits on any mattress and allows you to adjust the temperature of your sleeping environment, providing the optimal temperature that gets you the best night's sleep. With the Pod Cover's dual zone temperature control, you and your partner can set your sides of the bed to as cool as 55 degrees or as hot as 110 degrees. I think generally in my experience, my partners prefer the high side, and I like to sleep very, very cool. So stop fighting. This helps. Based on your biometrics, environment, and sleep stages, the Pod Cover makes temperature adjustments throughout the night that limit wake-ups and increase your percentage of deep sleep. In addition to its best-in-class temperature regulation, the pod cover sensors also track your health and sleep metrics without the need to use a wearable. Conquer this winter season with the best in sleep tech and sleep at your perfect temperature. Many of my listeners in colder areas, sometimes that's me, enjoy warming up their bed after a freezing day. And if you have a partner, great. You can split the zones and you can sleep at your own ideal temperatures. It's easy. So go to 8sleep.com/Tim, spelled out 8sleep.com/Tim, and save $250 on the pod cover by 8sleep this winter. 8sleep currently ships within the US, Canada, the UK, select countries in the EU, and Australia. This episode is brought to you by Nordic Naturals, the #1 selling fish oil brand in the US. More than 80% of Americans, that's probably a lot of you listening, including me, because I do measure my omega-3s, do not get enough omega-3 fats from their diet. That is a problem because the body cannot produce omega-3s, an important nutrient for cell structure and function. Nordic Naturals solves that problem with their doctor-recommended, and in fact, this brand was recommended to me by one of my doctors, Ultimate Omega Fish Oil Formula. So the Ultimate Omega Fish Oil Formula for heart health, brain function, immune support, and more. It's incredibly pure and fresh with no fishy aftertaste. So I have been taking Ultimate Omega for the last 2 months or so, and this fishy aftertaste issue has been a problem for me, and has actually, with other brands, induced some nausea after a few days. And Ultimate Omega has been as clean as a whistle. I've had no issues whatsoever. And if you are vegetarian or prefer to alternate, I ended up alternating 2 products. And that is #1, the Ultimate Omega Fish Oil Formula, and also the Algae Omega, which is plant-based EPA and DHA. That's also from Nordic Naturals. So I ended up getting both of those products, and it has improved my recovery from workouts. It's improved my sleep. It has improved my mood. And I know that because I pulled out a lot of other variables. In any case, back to the read. All Nordic Naturals fish oil products are offered in the triglyceride molecular form, the form naturally found in fish, and the form your body most easily absorbs. Their Ultimate Omega Fish Oil is offered in soft gels, liquid, and zero sugar gummies. Nordic Naturals fish oils are Friend of the Sea certified and sustainably made in a zero waste facility powered by biofuel. They're also non-GMO and third-party tested, surpassing the strictest international standards for purity and freshness. Want proof? You can visit their website, where they provide certificates of analysis for every one of their products. So go to nordic.com, Nordic, Nordic.com, and discover why Nordic Naturals is the #1 selling omega-3 brand in the US. And while you're there, use promo code TIM, T-I-M, for 20% off of your order. That's Nordic.com and code TIM for 20% off of the fish oil with no fishy aftertaste. All upside, no downside. Try it out.
These statements have not been evaluated by the Food and Drug Administration. This product is not intended to diagnose, treat, cure, or prevent any disease.